And we're off with our, I lost track, I think it's our fourth webinar now for this season for Finding Dory 5. This is, as I mentioned in the Telegram chat, probably the most important webinar that we'll give, because the sea state and the wind and your passage planning will probably make or break your passage, will make your passage enjoyable or challenging. I'm joined today by Julia Andres, who's a professional meteorologist. She will, and also a cruiser and a sailor. She will introduce herself, but before we start and before I hand over the microphone and the presentation part to Julia, a bit of logistics as usual. We ask the participants to keep their audio and video muted during the presentation part. I think Julia will do about 45 minutes of a general summary of weather expectations on weather and weather routing and the tools that we have. And then I'll join in with about 45 minutes on some practical tips on routing for your passage and some practical tips on reading sea state and clouds, especially for the squalls. As usual, please enter your questions in the chat channel. After the presentation part, we'll have a Q&A. We already assembled quite a bit of questions through the chat and to private messages from people in our Finding Dory group that I have already assembled and pre-prepared. But please, during the presentation, if something pops up in your mind, put it in the chat box. With this, Julia, I hand it over to you. I'll go on mute and then I'll take over after you finish. Go ahead, Julia, and welcome. And thanks again for joining.
Thank you. Thank you, Peter. Thanks, everyone. Thanks for joining us. I'll just jump right in. I'll share a bit of information about myself. So I've been a researcher in weather and climate since 2011. I've been a full-time liveaboard cruiser since 2016. Previously on a 44-foot monohull, now currently on a 54-foot. I've sailed with my kids. They're 7, 9, and 12 when we started sailing. 25 countries. I've done 1 Atlantic crossing, and I still get seasick. Now, why am I telling you this about me? Obviously, it's nice to know who you're talking to, but the reason why I think it's good to get a bit of background on the person who's talking to you about weather is because you're not going to get advice from me about how to win races, anything like that. You know, my advice is going to be quite conservative, and it's, yes, as I said, not going to win you any races, but hopefully it's going to give you a bit of sort of reassurance that even someone like me who does get seasick and who's not really a natural born sailor can get across an ocean. So, okay, what are we going to cover today? As Peter mentioned, he's going to present after me, so I'm going to sort of cover it from more of a technical aspect of what I know about weather and climate. But Peter obviously has the vast experience at covering the ocean, so he's going to add a really excellent sort of practical aspect to a lot of the things that I'm going to cover here. So frequently asked questions about the weather, some common misconceptions about weather and forecasting, and then I'm just going to jump into a little bit of the things that I think are important for different aspects of the crossing, and then I'm going to hand over to Peter. Okay, so first thing I want to talk about is weather models and weather apps. I'm sure you guys are all really familiar with this kind of thing now, because I'm sure you've all been watching the weather as you've been sailing around the place. But the important thing here is a weather app is not a weather model. A weather app is a resource that is going to allow you to download and display third-party weather model output. And we call them grid files. I'm sure you know that term also. But common apps that people use: Predict Wind, Windy, they're probably the 2 most common. LuckGrib is one. Basically any app you're going to use. It doesn't really matter what you use. Just some apps do have access to better quality weather model data, and that's an important consideration for the tool that you would like to use. Another thing you want to make sure is that the app that you are using is getting really frequent updates, because a lot of the weather models 6-hourly, 4-hourly updates, and you want to be trying to capture that information as frequently as you can. So the models that usually go into the apps that you guys see, the global models that are the most common, obviously, and I'm talking about spatial resolution here. And the reason I'm talking about spatial resolution, because obviously the question everyone asks is, well, which is the best model? And if you want to know the best model, if there's models not on this list that you're interested in, it usually boils down to the model resolution. In this case, we're looking at ECMWF, which is the Euro model that has a 9 kilometer resolution. That is why it is the best model. The other models here, obviously, they're all very good. They're going to give you very good information, but the lower resolution icon is currently 13 kilometers, GFS 22 kilometers. They've been promising a high resolution GFS that's going to be publicly available for a while, but it's still not cropping up in a lot of the apps. PWE, PWG, they're the predict wind models. They have a variable resolution. So they have 1 kilometer data near shore, 8 kilometer, so 1 kilometer in coastal regions, 8 kilometers near shore, and then 50 kilometers offshore. So, I mean, really looking at that for a passage, my recommendation is always ECMWF. But when you're offshore, cross-referencing with 2, 3, as many models you can get is also a really, really useful thing that you want to be doing. So I just want to show you this. This is actually not a map of Europe. This is a map of Southwest Western Australia. This is where a lot of my research comes from. But I want to show you this because this gives you a really good idea of what I mean by when I talk about model resolution and what it means for the quality of the forecast that you're going to get. So this is a rain forecast. And this is a model at a resolution of 100 kilometers on the left, and you can see the poor quality of the rain forecast that you're getting on the coast. And then this is 20 kilometers resolution. So this is about what you get from the GFS model. And then here on the right-hand side, this is more about what it's a bit slightly higher resolution than the Euro model, but you can see the advantage you get in terms of the spatial representation of something like rainfall really improves as you increase the resolution of your model. So if you want to know, that's really what you need to be looking at from a good model is, the highest resolution data that you can access and you can use is what you want to be aiming for. So this is probably something which I showed you Western Australia. This is the impact of model resolution for somewhere which you're probably familiar with, or if you're not familiar with, you will be familiar with in the coming months. And this is the Canary Islands. So Canary Islands are quite famous for their wind acceleration zones. And I just want to highlight here that on this particular day, you can see that the Euro model at 9 kilometer resolution is pretty well able to capture those acceleration zones. I would be willing to bet that you're probably going to see wind gusts slightly higher than what the model is showing. And you have also your pretty significant wind shadows following those islands as well. When you look over to the GFS model at 22 kilometers, you're not really seeing those effects. So if you can't, for whatever reason, access a high resolution model, you just need to be aware of the limitations, especially as you approach, coastal areas and islands and so forth, what that might mean for your forecast. I'm going to touch on limited area models really briefly, because I'm guessing that for most of you, although Florian, I know from what you were saying earlier, you're actually outside of this box, but most of you are probably currently still somewhere, within Europe. So you're where you can take advantage of a limited area model. So they cover a specific region. They generally tend to be higher resolution. There's a couple of limited area models around Europe that have, I think, a 1.5 kilometer resolution. So really, really useful for like afternoon thunderstorms, coastal sea breezes, things like that. The forecasts are short. Not very useful for Atlantic crossing, but whilst you're planning, trips down the coast, trips through the Med, and as you're heading out of Gibraltar, limited area models are going to be a really useful resource for you. So again, look for the highest resolution, and that's going to be where you're going to most likely get the best data. So just want to make a note on weather models and their limitations. Back in the day, weather models were computer generated output. They have very limited human review before they're released. Sorry, okay, that's a weather model now. Traditionally, when we would look at a weather forecast, a meteorologist would take this computer generated output, they would interpret that information, and then they would make it publicly available. But as this data is getting more accessible, especially for sailors, we are now looking at the computer generated output ourselves. There isn't a lot of human review. So what we as sailors need to be doing is we need to be doing that interpretation. And that means in some cases, you need to look at what you're seeing and, you don't necessarily need to take the data literally. You need to add the interpretation to get the best out of the forecast. And that kind of segues into this slide here, because this is a question, or this is a comment that, I'm sure all of us hear a lot. The model was wrong. And yes, weather models are wrong a lot of the time, but weather models still give you useful, beneficial advice. In this case, with this forecast, if you were having a look at these thunderstorms around Italy, into Europe, and you were thinking about potentially doing some sailing in the Northern Adriatic, you probably, if you have a look at a single point forecast and you assume you're going to be fine and you're not going to have any thunderstorms sailing, then you might look and you say to someone, oh, well, that model was wrong. But, as an astute sailor, as someone who knows you need to interpret weather models, you will probably have a look at that forecast and you will be like, well, there's thunderstorms in the vicinity. I'm going to be a little bit cautious and I'm going to interpret this weather model data and assume that, maybe I want to be aware that there may be some thunderstorms that are going to be happening near me. Okay, this is a slightly different interpretation of that. And this is, all models are wrong, but some are useful. So, this is again the interpretation aspect of it. So we're looking at a single point source forecast in the middle of the Tyrrhenian Sea. And you can see it looks pretty nice. It's looking really sunny, no clouds, low wind. I mean, not great for sailing, but and obviously, if you interpret this thunderstorm forecast, there's no thunderstorms at this particular point. But if we have a look at the Cape, oh, sorry, there we go. If we have a look at the Cape, I think we've got about 3,500 joules. So, we have a very, very high Cape. And again, interpreting the model and looking at extra layers, I think it would be fairly safe to say if someone were to sort of attempt a crossing from, say, Olbia to Rome overnight, that they would get some pretty severe thunderstorms based on those conditions. So just something to bear in mind when you're thinking about models and interpreting the models and, model error. The model can still be wrong, but it can still give you useful information. And it can certainly, if you interpret it appropriately and if you have a look at as many layers as you have access to, you're still going to get really good information from the models that you have currently available. I just want to make a really quick note on AI weather forecasting. This is certainly something that I think these two, ECM AIFS and Predict Wind AI, these have been released in the last 12 months. So since Peter and I last did this seminar, I'm just going to make a note here that these AI models are still quite low resolution, sorry. So you got a 28 to 31 kilometer resolution for the Euro AIS model and a 25 kilometer resolution for the Predict Wind one. So, they're not going to be giving you as high quality model output as you're going to get from a standard, numerical weather model at this point in time. These tools are probably going to be really interesting for you to sort of have a look at, and maybe if you're so inclined to do some validation with as you're going, making your ocean passages. But at this point in time, they are still fairly new. So, it's not really the time when you're offshore to sort of be like relying on something that's, cutting edge, bleeding edge technology. So just bear that in mind. I've also just made a note here of the Predict Wind Global Rain Radar. That is a tool, I think it's actually released just this week by Predict Wind. They are doing AI interpolation of satellite data, and they're showing it offshore as a radar representation. So if you guys are using Predict Wind, if you're interested in having a look at that data, just bear in mind where it is, what it's coming from. It's not really going to be a nice substitution for it. It's not going to give you what you're going to get in terms of high quality radar data from, the land-based radar information that doesn't go offshore. So I'm sure these products, if we were having this discussion for the crossing next year or the year after, these products are going to really significantly get very good very fast, but they're probably not going to be tools that I would be keen to rely on sort of for the passages that you guys are thinking of making this year. Now, just want to touch as well on a couple of forecast resources, because there are still meteorologists out there that are actually interpreting numerical weather prediction data and putting it out on charts. And these are really valuable resources for, I think, helping sailors get familiar with offshore conditions and what a grid file wind output or rain output might look like in terms of a synoptic chart, in terms of cold fronts and warm fronts and troughs. And then there's also the tropical hazards outlook, which gives you a bit of a long range summary. It gives you like a 3-week summary of, the conditions that you can expect in the Atlantic Ocean, which I think is a really useful resource. So this is just a copy of a synoptic chart that you can get from the Ocean Prediction Center if you're interested in having a look. I really like looking at what's going on in these charts, looking at what the forecasters have said in terms of the locations of troughs, tropical waves, which is something you'll be interested in when you get into the Caribbean, and just the sea state generally. And then you can overlay that and you can use what the forecasters have interpreted with this Ocean Prediction Center. And then you can reference that with, say, your GRIB output. So you can see what it means, what those conditions are likely to have. So this is a resource that I like to use. And if you're keen on sort of building up your knowledge in terms of how to interpret synoptic charts and so forth, I like to use this one because it's one of the few that has the detail over the ocean. It does also incorporate observations from ships. So you do get like real-time data of what's going on in the ocean, which I think is really useful too. This is a representation. This is the current tropical hazards outlook. This bit here is what you guys are going to be interested in at the moment. And what this gives you is, as I said, 3 weeks out, you get an indication of what the conditions are likely to be out in the Atlantic. So you can see here at the moment, we've got this like nice big patch of beige, which means that it's likely that the Atlantic basin is going to be below average rainfall. So, that means in terms of interpreting that as far as how that's likely to go for a crossing, you can look at that and you think, okay, that probably means we're going to have slightly fewer squalls, slightly fewer systems. So, it's a pretty good outcome, really. But yeah, just something to bear in mind when you are doing crossings, because if you are doing Canary Islands to Barbados, for example, that can be up to a 28-day crossing. So, anything that you can get that's going to give you some long range insight, I always think is really useful to have. Okay. So again, remember I do get seasick, so I'm going to talk a little bit about sea state and significant wave height because this is really important for me whenever I go offshore. Okay, so the significant wave height, which is what you'll see in weather forecasts and grid file output, that is the average of the highest 1/3 of waves, and that is measured from trough to crest. So if you're looking at the wave, a 2-meter wave, that is what it means. So let's break down the average of the highest 1/3 of waves. So what is that? Oh, I've got something over my screen. Okay, so what does that mean? Most of your waves are going to be less than the significant wave height, but you are going to get bigger ones. 1 in 10 is going to be larger. 1 in 100 is going to be 1.5 times larger. And then 1 in 1,000 is going to be 2 times larger. And then anything above that, you're going to call like a rogue wave. And, you will get waves like that, but, obviously very, very rarely. So just bear that in mind, when you're looking at, okay, significant wave height of 3 meters, you are going to see, if you're offshore, you are going to see, waves of 6 meters, just not very often. Okay, so how often are you going to get them? So if you assume you're going to have a 7 to 10 second wave period, then you're going to get 10,000 waves a day. That's a lot of rocking and rolling, but it gives you an indication of how that significant wave height is going to impact what you're going to see on the boat. So, you are going to expect that on a day offshore, you are going to see some pretty decent waves if you say have a 3-meter or a 2-meter significant wave height. Peter's going to mention this. I'm just going to talk about it here. Sea state is probably the thing that on your passage is going to be the most important determinant of the boats that I've worked with when I've done weather rafting across the ocean. It's usually the sea state that people complain about. It's nothing else. And yeah, often on this particular crossing, the sea state gets complained about the most when the winds are light and, you have a big swell and the boat is just at the mercy of the waves and the wind is not really able to sort of do much to it. So it's definitely something which you want to think about because it is really going to impact your comfort and it's not easy to get away from. So this is just a windy overlay of your wind forecast. I just want to really quickly talk about this because this is a good breakdown showing you the different components of the sea state, where it's coming from, what you can expect. So obviously you've got your wind and you've got a wind wave coming from that. That'll be a slightly shorter period. Your wind wave is usually going to be like 5 to 10 seconds. If you're not fetch limited, which you're not here, about a 17-knot wind, you're going to get about a 2-meter wave. And yeah, that should be it's in the direction of your wind. It's going to be reasonably comfortable. You do have to, because we are crossing the middle of the Atlantic, you are going to get swells coming from the north, and sometimes you will get swells coming from the south as well. It's more common, and what you will be more impacted by is the swells that are coming down from the north, especially if you have a big North Atlantic storm, and one that does travel quite far south, which is something that's going to be interesting to remember as we move on and we talk about El Nino. But anyway, so what you will get is you will get your standard wind wave, and then you'll get your impact from potentially a swell from the North Atlantic, and also potentially a swell from the South Atlantic. So I like the way this breaks it down, and you can see how the wave is broken down and what you can expect. In this particular case, you've got a nice strong wind wave. That is your dominant wave. That's the one you're going to feel. The other two, they're going to be very long period. You're not really going to feel them in this case. But again, in some cases, you will get a situation where you'll get, like a 2-meter swell pushing down from the North Atlantic, and then that will interact with your wind wave, and you will see an impact from that. So that is something you want to watch for. Okay. So now we're going to move on and have a quick chat about squalls, thunderstorms, and wind gusts. My discussion here is, probably a bit dry. It's a bit sort of theoretical. Peter's got some really great slides on this coming up, and I'm looking forward to hearing what he has to say, because I always learn a lot from Peter when he talks about this kind of thing. So, the squalls and the cells that you are most likely to experience as you're crossing are single cell squalls. These are small, brief, usually, hopefully, weak storms that grow and die within an hour or so. You're going to see loads of these on your passage. They're typically driven by local heating effects. So that means, and they're more common at night. So basically what happens is the sea generally keeps its heat. The air above the sea loses its heat. So you get this small areas of instability overnight over the ocean, and you get squalls. You'll get squalls in the afternoon, but you will tend to get them more in the evening, which is never very fun when everyone's trying to sleep, but it is just the way it happens. These single cell storms may produce straight line winds, depending on their life cycle, the cycle they are. Sorry, they will produce straight line winds, and how you feel them will depend on their life cycle. But Peter's going to talk about that. You may get brief heavy rain, light rain. You may get some lightning. Often, depending on where you are, sometimes you'll get a bit of rain, sometimes you'll get nothing. But we've got clues to help you sort of interpret what you might see from a cell. You're not going to see these systems on your model output or really on satellite data. They will be visible on your onboard radar, but you don't really have cues from, don't have a lot of great cues from a weather forecast on how these storms are going to be and how they're going to impact you. Again, I'm making a generalization here. They usually have a small plus or minus 10 knot impact on wind speed, but that can be bigger. It is very specific to the condition. So I'm just making some generalizations here. The other type of system that you can get, this is very rare when you're offshore, and this will be in forecast. So you'll be able to sort of plan for that and manage this. But a multi-cell squall line. This is a nice satellite image from a few years ago of a pattern here. And what these systems tend to do is they're caused by instability in the atmosphere. So as one storm grows and dissipates, it kind of creates the conditions that then allow another storm behind it to develop. So you'll get a line of squalls and storms that will move across a region. Each individual cell will only last for 30 to 60 minutes, but the entire system will last for many, many hours. As I said before, these are driven by synoptic effects. So you are going to see these on your weather in your forecast, and you'll see them in satellite data. These do tend to be stronger storms, cause more damage, but as I said, you're going to know about these in your forecast. So you are really unlikely to be taken surprised by something like this. This is just important from a forecasting standpoint. The winds you experience in a squall, they're not wind gusts. Like your wind gust forecast is defined by something else, because this is something that people talk to me a lot about. They have a squall that comes in, they've had a look at their forecast gust, and it says 34 knots, and then they end up with 47 knots, and they're like, the forecast was wrong. I mean, yes, it is wrong, because the winds are obviously stronger, but your gust forecast in a weather model is not really accounting for the wind speeds within a squall. So that's just really important, when you're thinking about sail planning, when you're looking at, going through an area of squalls, just don't use that wind gust forecast as your determinant for, what you're going to do with your sail plan, because that's not really relevant to what you're going to see in that system. Okay, so here's a couple of clues from me about, what you can expect. And because I've talked about the fact that you may get different conditions from these squalls, but how do you know, how are you going to sort of be able to pinpoint what you can expect? It can be difficult. And the boats that I've routed, they're in the same ocean at the same time, separated by 60, 100 nautical miles, and, very different conditions. And then sometimes everyone on a passage gets hit by, 50 knots from a squall. But the clues that can help you on your passage are previous squalls. Like if you had a squall an hour ago and, you had a really, really big wind shift, you had a plus or minus 20 knot wind shift, you can expect you're going to get that again because, you're in the same ocean, you've got the same conditions. So the squall is likely to do the same thing. If you've got a low cloud base, you've got more instability, you've got a lower condensation level. So, the storm has got a greater chance of becoming more intense. So it's got more energy in it. So a low cloud base means that the storm could be more intense. If the cloud is really high, that means it's obviously got a lot of energy. So, it could be more intense. If you're traveling in waters where the sea surface temperatures are warm, as we were talking about at the beginning, before we started this, sea surface temperatures that's where a lot of the energy all the energy for offshore squalls comes from. So if the sea surface temperatures are high, if they're higher than usual in the area you were in, or if you're going into an area where the sea surface temperatures are increasing, then you can expect the squalls to be more intense. One of the things that is going to make your squalls less intense or, potentially less likely to happen in the first place is Sahara dust. When you're making your way down, from the Canaries to Cape Verde or even out of Gibraltar down to the Canaries, you will sometimes get significant plumes of Sahara dust, and they will sort of help to sort of suppress convection and, just sort of prevent the development of thunderstorms. So they're a bit gloomy, but, does mean that you will not get storms. And you do tend to have this pattern here where in this part of the ocean, squalls are less likely. Doesn't mean it's not going to happen, but once you get over here, the squalls do become a lot more likely, and you can see that reflected in the Cape's not even registering here, and your Cape is increasing up to over 1,000 kilojoules here. Sorry, 1,000 joules. I'm assuming everyone knows Cape, convective available potential energy, a really, really valuable resource for you to use, I think, as sailors in terms of it's really important that you be looking at Cape and understanding what it means and how that can affect you. So if your Cape's above 1,000 joules, then that means that thunderstorms are likely. And basically beyond 1,000 joules, as that goes up, it means your storms are going to get more intense. And if you do get like really high numbers, like 3,000, 4,000, then basically any degree of instability is going to create a squall. So it basically means if you're over the ocean at night and the sea surface temperatures are warm, yes, you're pretty much guaranteed. It's just a question of whether you're going to be able to dodge them. Your onboard radar is a really, really great resource for localized squalls. Your weather forecast satellite data. Sometimes you will get in your forecast a pretty good indication of, you get like the patchy rain offshore, and that is a good indication as well. So you always need to be looking at that information. But generally, your weather forecast and your satellite information is more going to give you information on larger systems that appear at a synoptic scale. Okay, so going to touch on hurricanes and hurricane season. Even though you'll be traveling across the Atlantic outside of hurricane season, it's important to talk about because just because you have a season that is mid-May through to about mid-November, you can get tropical storms outside of that season. So some people just think that doors are closed and it doesn't happen, but it does happen. It is rare. It is really unlikely that it's going to impact you, but it's just obviously you're going to be crossing an ocean. You're going to be away from help for a large part of that. So it is important to just touch on these things that may or may not happen, especially, here you're looking in sort of late November to December. This is when, if you're thinking of crossing with the Ark, this is when some people will be starting to set off. So there is a really small chance that you would get tropical storm activity. These storms are very, very well forecast. It's probably some of the most well forecast storms on the planet. So it's not likely one's just going to crop up and no one's going to know about it. But it's just important that you're checking the resources of what the likelihood is when you go offshore to make sure that you're not caught by surprise. And this is just a spatial view. This is where storms develop. This is the peak of the hurricane season. This is mid-September in the Atlantic. So you can see like storms can crop up anywhere. And this is the cyclone points of origin towards late November, when some of you'll be thinking of crossing. Again, you can see how rare they are. This is like the number of storms that are developed in 80 years. So they are very rare, not something you need to be panicking about. It's just something you always need to keep in the back of your mind and make sure that you're checking those resources. You just need to understand that, it is not hurricane season, but that doesn't mean that there is zero chance that you're going to get a hurricane. So just worthwhile remembering that. Okay, I'm just going to give you a really quick introduction to the trade winds. This is what's going to propel you guys across to the Caribbean or South America or wherever your destination is. These are some of the most reliable, consistent winds on the planet. They're driven by a global circulation that I'm not going to go into in too much detail, but generally it is for most of your journey, it's a northeasterly wind blowing. They blow year round. The reason they generally tend to be the strongest, towards Christmas, and obviously the reason why people don't use the trade winds to go across the ocean in the summer is because of the likelihood of tropical storms. But the trade winds are still there. They don't disappear. They blow year round. This is just another view of it. This is a nice representation of the Azores High, which at the moment is doing the right thing and sitting above the Azores. So the southern arm of the Azores High is where the trade winds are, what we will use to get across. Up here, this is where you're likely to see storms and so forth develop. And if you get a big enough storm, it's going to push swell down into the southern arm of these trade winds where you're going to be going. And very occasionally the storm will sort of come down, and you'll get like a breakdown of the trade wind circulation. But in November, December, January, when you guys are thinking of doing that passage, again, that's really rare. But you just need to be aware that it is potential that that's going to happen. There is a potential that's going to happen. Okay, this is another representation. This is just looking at a rain and thunderstorm overlay. The important things to look at here is you've got this instability up here, very little instability here, especially if you dive down south. If you dive down south to about 14 degrees, the thing you do have to be aware of is this area here. You might know it as the doldrums. Meteorologists will call it intertropical convergence zone. Basically, it's where there's not a lot of wind and there's a lot of thunderstorms. So if you are thinking of doing an arrival in South America somewhere, then this is something you just want to be aware of, is like, where is the intertropical convergence zone located, and how do I avoid, going into it if I can. So that's that. Okay, so just a summary of that. Traditional trade winds crossing is below 14 degrees north, that's, just below Capo Verde. The trade winds do tend to be the strongest and most stable December through February. There is this term you may have heard, the Christmas trade winds. A period of increased wind speeds around Christmas. Winds can blow consistently around 25 knots. When we did our crossing back in 2019, we did a Christmas crossing, and the aim of our Christmas crossing was to take advantage of the Christmas trade winds, and we were very lucky. We got some really strong, consistent winds that made our passage fairly comfortable. You do get year-to-year variations in the trade winds, and Peter will, because Peter is the expert, he has done many, many crossings. But people who I've spoken to have done multiple crossings tell me the only thing that's common is how different every single one of their crossings has actually been. So there is a massive amount of variability in the winds and just the conditions generally. But if you're trying to sort of compartmentalize, how the weather is influenced by factors that we can manage or we can monitor, two things that do influence the trade winds are the North Atlantic Oscillation and El Nino. Now, I'm going to briefly talk about the North Atlantic Oscillation, but it's not really the thing that everyone's talking about at the moment. And it is in a neutral phase. So usually if you have a positive NAO, you get stronger trade winds. If you have a negative NAO, your trade winds tend to be weaker. At the moment, your North Atlantic Oscillation is pretty much neutral. If you are particularly interested, there is a link here that you guys can access that shows you the forecast for that. So you can see if that's going to impact you. But really the thing that we want to spend the time talking about, and the thing that is probably going to be quite an impact on all you guys and your crossing this year is El Nino, and whether or not it's going to become a super El Nino or not. But at this stage, the people who are monitoring El Nino, the people who are forecasting it, they, as I say here, they believe there's a 63% chance that it will be the strongest El Nino on record. So what does that mean for sailors in the Atlantic basin? Well, the big thing for the Atlantic and El Nino is it does suppress tropical cyclone activity in the Atlantic, which is great, because obviously the cyclones in the Atlantic can be catastrophic, really dangerous, cause a lot of trouble. The reason why it's suppressed is because there's something called increased wind shear. And that's something we're going to talk about a little bit in a moment. We are also going to get a more southerly track for winter storms. Now, you guys need to think, we talked about the sea state. So what that means is as those storms can push further south, that means there's an increased likelihood that swells from those systems may reach you. So probably what all these things together are going to mean, especially when you talk about lighter trade winds, is it's probably going to be a year where there is going to be a much more southerly track for people doing crossings. Again, the crossing is going to be in November. I'm just sort of hypothesizing here, but these are the factors that we look at, and these are how we sort of make a determination. Another thing that the super El Nino is likely to do is increase sea surface temperatures. So I put some question marks here behind more squalls. And the reason I've done that is because most of the information that I give to you is I've researched it. There's peer review papers. People have sort of got a lot of information on it. I couldn't find anything that, has this direct correlation with more squalls when there is an El Nino year in the Atlantic. But as you get less wind to mix the layer of the atmosphere above the ocean, and as you get increased sea surface temperatures, the natural result from that is that you will have more squalls. So, you guys are probably, that's something that you should bear in mind, because that's probably something that you guys are going to experience. Another thing I want to say about El Nino is it, from a meteorological standpoint, from a climate standpoint, it generally is associated with a high level of uncertainty. All of the most extreme weather events that we tend to get, the heat waves that most of you are probably experiencing right now, fire weather, things like that, all of these extreme things do tend to happen during El Nino years. So I guess for you guys, the take home from that is increased uncertainty. You probably want to factor that in, and maybe if you're going to be making sort of, when there's that level of uncertainty, if you're throwing up between, do I make a bold choice, do I make a conservative choice, that uncertainty sort of pushes me towards, well, I probably should consider making the conservative choice, because that's sort of what we tend to see when El Nino is coming, and especially if it's going to be stronger than anything we've been recording before. Okay, so I'm nearly at the end. I'm going to hand you over to Peter, but I'm just going to really quickly flip through just some notes of mine, just some things that I think are salient on different aspects of the journey. So first thing, generally, you guys do, I'm pretty sure probably all do this, is getting to the Canary Islands. And my advice there is do not wait too late to make your run. I think Peter's going to give you some more information on timings, but it can be hard if you don't want to spend a lot of time in the Canaries. They're beautiful. They're really lovely, but people who leave that run late end up dealing with winter conditions, winter storms in the Atlantic, and it does make that journey very difficult. And very difficult to find a weather window that's going to be, fully comfortable. And so, if you're concerned about that, if you're worried about that, you probably want to be thinking about, I want to say September, is probably like end of September is probably the latest you want to be there. But really Peter's the expert on that. So I'm going to leave that for him to sort of give you some more info. You are going to get colder air and sea temperatures. Not really much of a big deal, but you'll need, it will be temperate. So, it will be quite cool on that. You won't be in the tropics just yet. Do aim to stay off the continental shelf of Morocco, of Africa, sorry. I talk about big swells here, but there are other reasons to do it. I think this happened to some Dorians last year, and we certainly experienced it. There were some fishing boats off of Morocco that were very, very far out, very, very small to detect on radar, and without AIS signatures that did make us very, very nervous. So we just steered clear of them. So that is some advice that I have. And the final point there is we talked about the local effects. There are a lot of like local wind effects, local wave effects around the Canary Islands. So just be prepared for those as you're landing. If you're landing like Arrecife, I think I can't remember the Lanzarote. If you're landing Lanzarote is pretty okay. But as you get down to Gran Canaria and the other islands and Tenerife, the local effects do become a lot more marked. So Canary Islands to Capo Verde. Again, watch out for your local effects. Remember those long wind shadows. If you do find you're leaving and you don't have a lot of wind, try moving, you may be in a wind shadow. So just factor that in. I'm just making a note there. Check for tropical storm development. I'm probably going to say that a lot of times because I just think it's important. You are going to be moving from this, you're going to go from your temperate climate to your subtropical climate. So it's going to get warm, it's going to get nicer. I really enjoyed that part of it when we left. You're going to get increased squalls. This passage is nice because it's 5 to 7 days. So, you're going to have a pretty robust forecast for the whole thing. You're not really going to have any surprises. I think a 7-day forecast now, we're pretty happy with that in terms of its validity. So Cape Verde to the Caribbean. Tropical weather sailing in the trade winds, just beautiful, warm, doesn't get better. 12 to 15 days. But you're not going to have, you will have a weather forecast, but you're not going to have a really reliable weather forecast. You want to be checking your models, comparing them. If all the models happen to agree, you can have a lot more confidence in a longer range forecast. But it's unlikely that, the models are going to agree, and you just need to be paying attention to, don't check the forecast at the beginning of your passage and just think that, it's not going to change, because it will. But I'm sure you guys will be checking your forecast anyway. You should be far enough south when you're doing this passage to avoid the major influences of North Atlantic storms. But I actually wrote that last year when it wasn't El Nino. And so, just bear in mind that, you could have that chance. But as I said, the swell forecasts are really, really accurate and detailed. So you shouldn't be taken by surprise with anything there. Some of the feedback I had from other cruisers who did this is if you are planning on doing like Capo Verde to Barbados or anywhere north of that, you have a really sort of like due west passage. And especially from people in monohull, they did find that, they were taking a lot of waves on the beam. So, they had a really exaggerated roll. So just sort of think about, if you are going to Capo Verde, maybe don't try to aim for Antigua or St. Martin. I had one family who were trying to aim for San Salvador and the Bahamas, and they ended up having to change because it was too uncomfortable. It was a bit of a crazy thing they were trying to do. But anyway, and again, score frequency is going to increase as you move west. So that's that. So if you do want to go Canary Islands to the Caribbean without stopping, this is a longer passage, 16 to 28 days at sea, depending on your conditions, obviously depending on your boat. The traditional route here is, I can't remember what we call it. I think it was Peter's Golden Route, but and down to 14 degrees, and then turn west. And again, this is probably with the conditions that we're going to see: El Nino, lighter trade winds, potential greater influence from North Atlantic storms. Probably you guys are going to be looking at more of a traditional route for this year. The Rumline route tends to be shorter. It is potential for a more direct downward run with less swell on the beam, but that is really contingent on the conditions. And when Peter and I were having a chat about this yesterday, we both felt that, based on El Nino, based on everything that's going on, that, probably a Rumline route is not going to be something that a lot of you will end up tackling this year. But I'm going to put that because I know Peter's got a lot of really useful notes on that. So everything else I've already talked about, so I'm not going to go into much more detail there. I'm just going to finish up with just some notes on finishing in South America. I'm not sure if this is something that any of you are planning on doing. This is the shortest. Capo Verde to, I think, Suriname is about as short as you get. You can, I'm pretty sure most people can get that done in 2 weeks. The biggest thing you have to be worried about if you are going to do a South America arrival, I've just put this as a current map from Wendy. So you can see that if you do, and when you approach the coast, you do get quite strong currents. Everything else every other passage that you're going to get like a beautiful half knot to a knot current pushing you along, helping you on your journey, which is just wonderful. But once you get down to South America, the outflows from the Amazon and just the general outflow from the fact that you're approaching the doldrums or the reverse flow from your North Atlantic, it's just going to give you some countercurrents that could make for a really slow and really uncomfortable trip, especially if you've got the winds against the current. It can make for very steep and uncomfortable wave conditions. So finishing in South America, it will allow for a more downward sail from Cape Verde. It is the shortest distance. Because you're going to be the warmest, you're going to be the lowest latitude, you're going to be closest to the intertropical convergence zone. You are more likely to experience intense squalls. And as I said, I'm just highlighting here, really watch out for currents as you approach South America, because you're going to want to make sure you avoid some counter currents. I'm just going to finish here with some notes about the current forecast. The windy current forecast, I think, is a model called HRRR. It's not great. I've sort of used it for some Gulf Stream stuff, and I've validated it against some people who I've routed into South America. And we have found that this RTOFS model is a better model. It tends to be more accurate. It doesn't have the duration, so you can only get a short forecast, but you obviously don't need it for too long. You can get it in predict wind routes using RTOFS, which is really good if any of you are using predict wind. But if you don't want to if you don't want a predict wind subscription, or you don't want to pay for their service, there are other ways, other tools in which you can use to access the RTOFS forecast. And my favorite one is LuckGrib, which is an app that you can buy. I think it costs you like $10, but it's really worth it if you are interested in really accurate current forecasts and you don't want to use predict wind. And I can provide more information on that to people if they need it as well. So that's pretty much it from me. I'm going to be living vicariously through you guys on your journeys until I get back on my boat in September. So happy sailing. And Peter, I'm going to stop sharing and hand over to you.
Thanks, Julia. As usual, very interesting, and lots of information. It was also interesting that the Cape forecast you showed for the Mediterranean, actually with the 3000 EULA forecast, is almost the forecast that we have for the next couple of days. And I'm watching the dark clouds approaching from the lightning storm approaching through the window at the moment. So it was almost the forecasting that we have at this moment. Let me see, where is my window? In just a second. I lost. One moment. Let me share this. And I'm going back on my Zoom. Share. There we go. Share. Then now my screen should be up. Very good. So in my part of the presentation, I'll concentrate on practical information and some of the past statistics for weather routing, but also passage routing, which is not only weather routing itself, but also some taking into account some other factors. Most of you are at the moment in the mid, or many of you are in the mid. So some notes on routing through the Strait of Gibraltar. Some practical information and practical tips. First of all, it's a rather complex area to sail through. First of all, you have the tides, and the tides by themselves, even if you only take the tides are quite complex. And very often you have different tidal streams at the edges of the strait versus in the middle of the strait. So for that, you look at the tidal atlas, and I'll show you a screenshot in just a moment. Beyond the tides, you also have a permanent west-east current between half a knot and 2 knots, which is always there because the water in the mid is vaporizing faster than it can be refilled by currents, by rivers. So you always have an almost permanent current that goes into the mid via this very narrow Strait of Gibraltar. I'm saying half a knot to 2 knots, but possibly this might be higher if there is an incoming swell from a North Atlantic low pressure system that is pushing the sea mass into the mid. And again, they go through a very narrow trough. So not only the tides, but also the currents can be quite strong. Beyond that, if it wasn't complex enough, there is quite a bit of funneling. Julia mentioned this, and I will go into this also for the Canaries, because you have two land masses. The wind funnels and gets accelerated in this very narrow passage. So it is not unusual that, let's say, 100 miles off Gibraltar, you have nice, comfortable 10 knots of wind. But then in the Gibraltar Strait itself, it is accelerated to 20 or 30 knots or even more. In all of that, do avoid winds against tide. And then generally do not cross on a westerly wind. So do not plan on tacking upwind through the Strait of Gibraltar, which is very difficult because you have the tides, you have the currents, but also because there's a lot of traffic, and it's a very narrow passage, which is also dotted with orca risk areas as well as fishing nets. So by all means, do not cross on westerly. Definitely avoid the orca high risk areas. So watch orcas.pt, who does a very good logging of the instances where people have seen the Iberian orcas or where incidents have been logged. And at this moment, they are very, very active. I think it was 2 days ago where we had 3 attacks in a day of the southern part of Portugal. If it is not complex enough, do avoid the floating tuna fishing nets. And where they are, the fishing nets depends basically where the tuna is. But where the tuna is also where the orcas are. So that makes navigation a little bit tricky. So where the tuna nets are depends on the tuna season, also the sea temperatures. Typically, you can also see or predict where the tuna nets will be because that's also where the orcas are. They are mostly south of Spain and Portugal, but those tuna nets are very well marked with cardinal markers. But the ones just south of the traffic zones, more on the Moroccan side, are not marked with navigation maps. And those tuna fishing nets are treacherous because they are long floating nets, sometimes half a mile or even a mile long. And they're floating on the surface, or the top is floating on the surface. So for sure, you will catch it in the propeller or in your rudder. What most of the people seem to be worrying about is the very high cargo vessel traffic through the Strait of Gibraltar. I would not be too worried about that. Yes, it is dense, but it's very well regulated, and it's basically 2 highways, one going west, one going east. It's very easy with AIS these days to plan when to cross the cargo vessel traffic. So that is pretty straightforward, but it is an added complexity. Keep a sharp lookout for smaller fishing vessels. Typically, they roam around, of course, where the fishing nets are. Many of these small fishing vessels are not even bigger than a big dinghy. So many of them are not on AIS. Monitor channel 16 if you approach one of their nets. They will call you on channel 16. An added complexity is there's a lot of smuggling activity between Northern Africa and southern Spain, southern Portugal, Gibraltar. My personal preferred route, but take this with a bit of a grain of salt, because that is my personal experience, and this is how I prefer to route when I go from east to west through the Strait of Gibraltar. Taking into account, of course, the wind and the fishing nets and the orca spotting, I like to cross east-west on a moderate easterly. I tend to leave Gibraltar preferably in an early morning, at the tide of Gibraltar, high water +3. I go straight south to the Moroccan coast, then stay in a 20-meter contour very close to the Moroccan coast. The 20-meter contour is the magical contour. Normally, orcas stay in deeper waters than 20 meters. And then as of Cape Spartel, which is the northwestern corner of Morocco, then I start heading towards the Canaries. But as Julia mentioned, I try to stay at least 100 nautical miles offshore from the Moroccan coast. I always advise people to try to cross from Gibraltar or Tangiers or the southern part of Portugal or Spain towards the Canaries, somewhere late August, early September at the latest, unless you're willing to wait for a good weather window. And we witnessed this with Finding Dory IV last year, and almost became an internal joke amongst us that as of September, all the way up to January, per month, there was only about a 1 week opening that we had to do a crossing to the Canaries. So if you're willing to wait for a longer time, for a couple of weeks, in Tangiers or Gibraltar in the south of Spain, south of Portugal, to cross to the Canaries, and you're willing to wait for 2 weeks, for 3 weeks, then that's still fine. You will still get a good weather window. But if you are more limited in time, and typically people tend to go to the Canaries, then leave their boat there or work on their boat in the Canaries. So they are a little bit more time constrained. So the higher chance for a good and a long weather window would be to cross at the latest August, early September. We talked about the tidal atlas. So this is a page from my Bible with the tides. And if we zoom into that, you see how some of the tides are not consistent in one direction throughout the strait. So you have closer here in this particular tidal snapshot, which is 2 hours before high water in Gibraltar. You have the tidal stream going east, closer to the coast. And actually in the middle, it's going west. So that shows a little bit of the complexity of the tidal planning. If you look at the wind, this is my ideal wind. This is a very moderate easterly wind between 12 and 18 knots, which will carry me nicely through the strait. I try to avoid the scenario like this, and we've seen quite a bit of this pattern now in the last couple of weeks. So I try to avoid these very strong easterly winds, because if anything happens and you're delayed and you have the tide and the current, which is always against the wind, turning against you, this would be a very rough ride. I definitely try to avoid westerlies. So here, even though it is a moderate 18 to 25 knots westerly, it still goes straight into the Gibraltar Strait. So this is definitely a wind which for me is a no-go to go east-west through the strait. Again, on the orcas, on orcas.pt, you have good heat maps of the occurrence of the orcas over historic period. So this is a heat map with in red the higher occurrences, but that shifts a lot. And we've seen this over the past couple of weeks, where the orcas are now shifting more towards the northwest of the southern tip of Portugal, where before they were more in this area, probably around Tarifa or a little bit west of Tarifa. So this is the heat map, which in generally the safer areas. But all of that is still prone to orca behavior, so this is not written in stone. There are people that advise going east to west to follow the safe zone in a 20-meter contour all the way up to Cadiz, and only then turn off to the Canaries. Personally, I prefer more to go, as I said, from Gibraltar straight to Morocco, then follow the 20-meter contour along this coast, and off Cape Spartel, this point over here, I go and dive about 100 miles offshore towards the Canaries. Then you've gone through the state of Gibraltar, going south to the Canaries. Again, advice is to do the transit before late August or early September, unless if you're ready to wait for a weather window. Avoid headwinds going south. Some of you have done ocean passages before. Going into the wind, tacking into the wind in an ocean is never a good idea. You might have a weather window where there is no wind. So unless if you have sufficient fuel, try to avoid excessive motoring. I've been on boats where they only have about a 3 day of motoring. So look at the weather forecast. As Julia said, the weather forecasts for a crossing from the Gibraltar Strait into the Canaries, which is typically a 4 days, 5 days passage at the maximum. The weather forecast is pretty accurate, up to 4 or 5 days in advance. So if there is no wind, make sure that you have enough fuel to get you to the Canaries. And again, try to stay off the continental shelf. So this is 100 nautical miles or more west of the Moroccan coast. Because of fishing nets, cargo traffic tends to follow more the African coast, going north or south. Unmarked fishing boats, not on IS, and very often you also have a freaking fog along that closer to the Moroccan coast. So you're now in the Canaries. You're preparing your crossing. This is a slide I stole from Julia. The trade winds established in 1492. Not true, of course, but this is the first time probably that is known where the trade winds are used, with Columbus crossing the Atlantic. These are the stable winds that will carry you across. You see over here the typical northern depressions with the wind go with more westerly winds. Over here you have the doldrums around the equator with little wind, a lot of squalls, and then the trade winds turn more from the southwest below the equator. Again, I'm taking a slide from Julia over here, a little bit clearer in representation. The typical lows, which in the northern hemisphere turn counterclockwise. And then over here you have the trade winds. In the middle, you have the Azorean High, but also the area where the northern Atlantic depressions, the westerlies, will fight against the easterlies from the trade winds. So those two wind systems typically neutralize itself. So the fact that there is little wind in this area is not only because the Azorean High, but also because the two winds, the westerlies more north and the trade winds easterlies more south, will neutralize each other. And that changes quite a bit even during your passage. These are a couple of screenshots that I took from PredictWind over the last season, and it shows you some typical scenarios. So you see here the Canaries, Gibraltar, this is the Azores, Cabo Verde, a mid-Atlantic point, this is Bermuda. So here you see a very typical scenario. You have one low here, counterclockwise, a pretty big one, a pretty wide one. You have another one building up, all counterclockwise winds. You have your trade winds, and here they're quite moderate. And you see here the Azorean High, but also the area where the easterlies and the westerlies neutralize themselves. So what you try to do generally is try to avoid this no wind area. So your very typical route is from the Canaries, you dive south into what we call the Golden Alley, around 14 degrees north, sometimes a little bit further north is possible, a little bit further south is possible, to catch these trade winds. So a very traditional route is towards Cabo Verde, more or less, and then start heading west towards the Caribbean. Another screenshot from, I think that was a week later. Here you see a bit of a different scenario. You see this Azorean High, and the area of no wind area has moved further north, has become much smaller in this area. So it looks like a good start from the Canaries, where you pick up the trades already from northern Morocco, and you would be in for a good start. You see towards the Caribbean here, and that very often happens that there would be a large no wind area in the Caribbean area. It all depends what the lows do in this area and how they neutralize the trade winds. But again, weather forecasts are not reliable for anything really beyond 4 or 5 days in advance. So at this moment, I wouldn't worry too much about this. If I am here in the Canaries and I'm planning to leave under this weather prediction, that to me looks like a good start, where I'm going to head into the golden alley of about 14 degrees north. I would not, if I leave, I would not worry too much that there is no wind here in the Caribbean, because it will take you another 2-3 weeks before you hit this spot. And by that time, you know, that no wind area might have disappeared. Another typical scenario, this was a screenshot, I think 2 weeks after the last one. Again, your typical North Atlantic lows. Remember, it's a winter season, so the lows come hard and frequent and furious, and they can be very large systems. So look at this beauty here, this depression, which goes almost from the Arctic down to the Canaries. This would look like a less optimum moment to start, because this Azorean high now is very low and is stretched all over the Atlantic. So if you would want to start with this weather system in your forecast, then most probably you would count on having to motor for a couple of days to get down south into the trade winds. Mind you also that I think this is a screenshot from November. This is late November. This is before the Christmas trades kick in, the stronger trades, which tend to start, as Julia said, end of December. And this year they lasted, I think, for about two months. So this would be a possible typical scenario that you have when you're looking at leaving from the Canary Islands towards the Caribbean or across towards Brazil, is this large no wind area. Which would entail that you would have to motor for 3 or 4 days to get into any of the trade winds. Now, all of these are weather systems and somewhere theory. Now, let's look a little bit at the practice. I took some statistical data from the ARC. As you know, the ARC is doing tracking with YB, with Yellow Brick. So it's easy to get historical data from the ARC YB website. You see, you probably know the ARC is leaving from Las Palmas and is heading to St. Lucia, to Rodney Bay. The red line is the REM line. By the way, the 2021 ARC was also the first ARC after COVID. So there were a lot of boats, not only in the ARC, but also a lot of boats which were crossing that year. I think the transatlantic crossing was closed the year before. Now, somewhere a psychological effect of that is that there were a lot of people eager to go to the Caribbean, and a lot of people were prepared to take risks. And the moment that you go north of the REM line, for me, in my book, you start taking risks. So you see here a couple of boats in the track. So all of these yellow lines are all tracks of individual boats. So here you see a couple of boats, and these are mostly boats in the racing class, in the competition class of the ARC, that took a chance. And you see here, there's one particular guy that really went north, you know, almost to the north of the latitude north of Morocco, before they start heading towards the Caribbean. The majority, however, followed the wise route, going south-southwest from the Canaries until somewhere the latitude of Cabo Verde, and then started to make their way west. By the way, this was also a very sad ARC. At that point, when the ARC was leaving, I was actually anchored for a couple of weeks off Las Palmas. So I saw the ARC leaving. And then already a few days after the ARC started, I saw already the first dismasted boats in the competition class coming back, limping back into Las Palmas. And these were people that took this risk and went into the low pressure systems, trying to use the low pressure systems for a higher crossing. Unfortunately, this was also the ARC where one French sailor lost his life when they had a crash jibe just at a crew change shift in the middle. So the crash jibe, two people were hit by the boom. One went overboard and unfortunately passed away before they were able to recover him. And the other one was seriously injured. The boat had to be abandoned and the people were rescued by a cargo ship. So again, we're cruisers. We are not regatta sailors, and we're definitely not professional regatta sailors. So be safe rather than sorry. Also, keeping in mind what Julia said is with extreme weather events, like we now predicting El Nino, predicted extreme weather events always come with large uncertainties. So you never know what the weather is going to do, and you won't see a possible extreme weather with, for instance, a massive low pressure system extending into your route from 2 weeks before you do your crossing. So here in the routing, however, it is a pretty typical arc crossing, south-southwest from the Canaries and then diving into the Golden Alley, somewhere around 14 degrees north, plus minus a few degrees. Another typical routing was the year after, 2022. Again, here, I think people were more warned or on the qui vive on more conventional routing after what happened in the 2021 arc. So you see here almost, well, nobody went above the rim line. So everybody was quite conservative in following south-southwest into somewhere the trade winds. You could see here the trade winds were quite high at the beginning. So people turned off west quite a bit above 14 degrees. But as you can see, probably here, people dived much further south because the winds slowed down. I did also crossing in that year, and we actually had to dive down to 10 degrees north to get some wind in the area, in the time frame that the arc was here in this particular time frame. We left, I think, a week after the arc. So by the time that here they had to dive so south, we were then somewhere leaving Cabo Verde, and we were somewhere at 10 degrees north, which is very deep. Normally, we don't go that deep. 2023 was a very slow arc. There was not a very strong trade wind. We had the Atlantic depressions, which were diving very deep into the Atlantic, neutralizing the trade winds. So here you see that the whole fleet, without any exception, took a much further southern route, diving down again to somewhere 10 degrees north. And you see that the whole fleet went very consistent. It was a very, very slow arc. I remember during that arc, actually, a couple of people abandoned the arc and went straight to their destination because they could not meet the timelines to drop crew off or pick up new crew. 2024 was a much, much faster arc, much closer to the rim line. You see a couple of adventurers here in the competition class that went above the rim line. But again, the typical curve, the banana shape, and people stayed quite a bit north of 14 degrees north. Remember, 14 degrees north, I call my Golden Alley because that's the average. But as Julie also said, every single passage, every single year is different. Sometimes you have to dive further south or further north. 2025 was a good year for a passage. We had reasonably calm weather above the rim line. So quite a few people took the chance here to go above the rim line. I'll show you a track what we did. We stayed above the rim line, but I'll give you some notes of caution in there. However, the majority kind of spread out. But here you can see it was a year, 2025, where we had much stronger and consistent trade winds, which stretched much further north than usual. So that allowed people to have a route which is much closer to the rim line. These are 6 of my past east-west transats. Forget this one. This is our last west-east transat. So here are my last 6 transats. The standard routing is the same as what we've seen with the ARC. So these are all on cruising boats, except one was a racing cruiser. This was the year where we had to dive really south to 10 degrees. This is this one here. This was a 72-foot racing cruiser, but all of them basically followed the same path. We dived, towards Cabo Verde, Often we made a stop in Cabo Verde, because it's nice to visit. We'll have a webinar on that, and then went almost straight west to destination. This route here is a different route. This is the route that we took last year, but this is very exceptional. I'll show you in detail here. We were on a regatta boat. We had 5 professional regatta sailors, open ocean sailors with us, who did the Volvo Ocean Race, part of the Volvo Ocean Race or the Ocean Race. We had a very big boat, a very fast boat. So for us, we were able to reposition the boat. We did average between 180 and 250, 260 nautical miles per day. When we motored, we could easily motor 180 nautical miles per day. So that allows you to have a much more competitive route, but also a route that if the weather forecasts turn out to be in your disadvantage, to reposition the boat 180 to 260 miles per day. So if somewhere a bad weather system is coming up from the north, we could dive south 250 miles per day quite easily. On a normal cruising boat, you can't do that. But nevertheless, I'm showing you this as an example, because even with the fast boat, even with the professional crew that we had, still, contrary to the predictions that we had, when we left from Gibraltar and we thought of going wormline straight to the Caribbean. But when we approached the Canaries, we actually could see a quite heavy weather system, a low pressure system coming in with 30, 35 knots of headwind. The boat could take that, but they would not have been comfortable, and we didn't want to take any risk. So actually see here in our route that we went over to Lanzarote and took shelter for 3 days before we continued our passage. So in here, then we followed the winds. We had very light wind regatta sails. So by purpose, we followed a route which was close to the Azoran High. And we typically aimed for like 10 knots of following winds, because then we could put our really big spinnakers up. We had spinnakers up to 850 square meters. We had a total sail surface of about 1,000 square meters. So we could easily sail with 8 knots or 10 knots of wind, downwind faster than the wind itself. But even then, you could see that at a certain point here, to avoid a low pressure system coming up, all of a sudden we had to dive south. So do not do this at home. Do not use it as an example. But I wanted to show this route. If you have a very fast boat, if you have a very experienced crew, it is a possibility. You don't have to go south of the rum line, but as we're all cruisers, I strongly advise you to aim south. So summarizing as a typical transat routing from the Canaries. First of all, your route aim is to get as quickly as possible into the steady prevailing northeasterly or easterly trade winds, wherever they might be, at what latitude they might be. And try to aim for moderate waves and try to route for a lower cape and a lower possibility of squalls. So that, in one sentence, is basically my golden advice. And of course, the question is how low, how much south will you go? And that depends on where the trade winds are, whether the Azoran High is, or where that no wind, that the vacuum is, where the westerlies from the North Atlantic will neutralize the easterlies, the eastern trade winds. So typically, the first 3-4 days out of the Canaries, you might still have a possibility of a direct influence from a northern low pressure system. So don't leave the Canaries when there is a big low pressure system reaching south of the Canaries, which will give you headwind, will give you a lot of waves from the side of your boat. But try to take either a low wind or a following wind down southwest, southwest to somewhere the golden alley of 14 degrees north, plus minus 2 degrees, depending on where the trades are. Once you reach the golden alley, as you've seen in this banana curve with all of the R crossings, then you get into the steady trade and you head more or less west, the VMG course. If, on the contrary, you stay too far north, you try to take risks or you try to stay closer to the rim line, then you have a strong possibility that you will be at the outskirts of a northern low pressure system, and you will get headwinds. You will get different weather fronts because the northern low pressure winds will bring in colder air that will collide with the warmer air and the warmer sea temperatures that you have. So you might have quite strong weather fronts and longer weather fronts, what Julia talked about. You will definitely get the bigger waves from the further north you are, the bigger the waves will be as a result of the North Atlantic low pressure systems, or you might have no wind whatsoever because you hit this Azorean high or no wind neutral convection zone. On the contrary, if you go too far south, going to the Caribbean, the further south you go, the more you increase your cape, which means that you have a higher risk of lightning and squalls. We come back to that later. So this is more or less the synopsis of what weather that you can get in terms of larger wind systems with the trade winds, the Azorean high, and the North Atlantic low pressure systems. But as Julia stressed, and I cannot stress this enough, there is no weather prediction system or model or software or application that will predict your local weather systems. So it is very important for you to keep a good eye on both the sea and the sky. Learn to read the clouds. And we'll go in this because this is so important. Don't forget what I mentioned in the first webinar. The East-West transatlantic is probably the easiest, most predictable, most used transatlantic, and probably also the safest, knock on wood, transatlantic. But even if you follow the Golden Alley route, you will get squalls and you will get local weather systems which are not predicted as such. A note on reading the sea. I'm repeating a little bit here what Julia says, but this is really important because it's not the wind, but it's the waves that will make you happy or sad. Remember the main wave characteristics, what Julia is talking about. You have the height, which is the average height between the crest and the next trough. You have the period, which is the distance from crest to crest. So the shorter the period, the steeper the waves will be. You have the direction or the angle towards your boat. So these are the three main characteristics that I look at in terms of comfort sailing and comfort routing. So on average, on your passage, once you get into the trade winds, your predominant wind waves will be 2, 3 to 4 meter high. They will have between 7 to 10 seconds of period. And they will have a wave direction of about 120 to 180 degrees towards the heading of the boat, which is noble because they're wind waves. So the wind waves will mostly have the direction from the wind. Unless if you have complex squall systems, you will have some residue waves from that. We'll come to that later. You often might have mixed waves. These are waves that come from different local weather systems squalls, or from the low pressure systems further north, or from somewhere a storm area further south towards the equator, towards the doldrums. So you might have waves, and Julia had a nice slide on this, which come from different directions. And these waves, when they mix up, they might create what we call standing waves. This is one wave which is climbing on top of another wave. So instead of having an average of 3 meter wave, all of a sudden you have another 3 meter wave, which is climbing on top of another 3 meter wave, and you have a 6 meter wave. That's also about what Julia stressed, is that the waves you see in your prediction are only averages, but you will have from time to time a standing wave or a rogue wave. That's why I'm always aware of the possibility of some rogue wave coming out of nowhere when we sail with open hatches. When we sail towards the Caribbean, we go more into the tropics as we get along. The people tend to become a little bit more complacent, start opening hatches. I have not had one single ocean crossing where we did not have a rock wave. At a certain point, you might be pooped from the back of the boat, and somewhere out of nowhere, like a 6 meter wave is coming in into your cockpit, running down your stairs, into your galley, into your saloon, all the way up to the forward berth, or at least soaking your cockpit area. And in the cockpit area, very often people have the side hatches in the aft cabins. Even if they're very small, you will get soaked in the cabins and the aft. Again, most of the waves are locally wind generated, which also means that if the wind is shifting and you have squall areas around you, you will get confused waves because they're locally generated. Do not confuse wind waves with ocean swells. Typically, ocean swells are bigger, have a bigger height. So it is not unusual that you have an ocean swell of 4, 5, 6 meters, which are very friendly giants. While the height of the wave might be very high, the period might be very, very, very long. So this is, for me, is one of the most beautiful views that I enjoy on an ocean, when you see these massive giants rolling towards you. But they have a period of 20 seconds, 30 seconds, 40 seconds, where your boat goes up, the gentle giant, maybe 4 meters, 5 meters up, and then sinking down in its trough. So you see the horizon, you see the sun coming up, or you see the moon rising, and then all of a sudden you see no moon, no sun rising anymore because you're in the trough. So these friendly giants, these ocean swells, are not dangerous whatsoever. Very often also the period is that long that they do not interfere with the wind waves. It is the wind waves to watch. Another slide that I took from, I stole from Julia. So as a summary, the waves on your passage between 7 to 10 seconds, but take into account, and Julia also mentioned this, these are 10,000 waves per day if you have 7 to 10 seconds period. This means that your boat will roll 20,000 times per day in average. Or if you sail on a monohull, this means that your hull and your horizontal platform will get slammed with side waves at least 10,000 times per day. On a monohull, you will roll left, right 20,000 times. So that, and we mentioned this in some of the past webinars for Finding Dory 5, if there is one thing that will get to you, and I've done now, I think, about 60,000 nautical miles in open ocean. Even for me, at a certain point, it gets to me because the rolling in the waves, and there is not much you can do about this, the rolling in the waves will tire you out, and you will get so tired of having to hold on to everything, getting out of bed, going and take a shower, take a pee, preparing food, going up on deck, and even sitting at the helm with the boat rolling left, right, and center. I have some very nice videos of that. It will get to you. So be prepared for that. And as we mentioned in, I think, the first 2 webinars, respect your sleep, make sure you are well rested, and these waves will try to counter that. All right. Something which is really, really, really important. I don't know if you caught this, what Julia said, although Julia said this several times, is that there is no model, there is no software, there is no application that does anything else but predict atmospheric predictions. These are the larger wind systems. So the local wind systems, acceleration zones, funneling, cloud-based systems, squall systems are not what you see in your prediction software. I stress this again. If in your predicament predictions you see that it says, okay, your average wind is 10 knots for the next 24 hours, and you might get gusts to 50 knots, these are atmospheric winds. These are not local systems. Even though PredictWind might predict a gust of 15 knots, you might get squalls, and you might get 30, 40, 50 knots in a squall area. Last year, unfortunately, was for those who crossed pretty early, was a time, I think the people that crossed, I think the first ones were crossing in Finding Dory for I think the first week of November, second week of November, and they had very, very strong squall systems. And these were not big, large front weather systems. These were very typical squall systems. So we had a boat that reported 50 to 60 knots of squalls. So keep that into account when you download your weather forecast for the next 24 hours. What is predicted as gusts in there is only atmospheric predictions. This is not the local systems. For the local systems, you need to look your eyes. You need to use your eyes and your radar. It also doesn't take into account funneling, wind shadows, and acceleration zones, which of course are only significant closer to islands, typically the Canaries. Julie already mentioned this. Definitely when you approach the Caribbean, also when you sail in the Caribbean, you sail typically leeward in the Caribbean. When you go north-south in the Leeward and the Windward Islands, you typically sail leeward, so you might have no wind in the shadow on the west of a Caribbean island, and then for a couple of hours, you sail between two different islands and you're hit by 20 or 25 knots of westerly. You also have this acceleration in Cabo Verde, arriving in Cabo Verde, sailing in between the Cabo Verde Islands and leaving the Cabo Verde. Now, beyond the local wind conditions, the only local wind condition that you need to take into account is of course squalls once you hit the Golden Alley. Just a quick slide. Julia mentioned this in a high resolution. You see this is an 8-kilometer resolution in ECMWF. These are the Canary Islands, and you see how far the wind shadow is stretching typically from Gran Canaria and from Tenerife. Remember that the highest point in Tenerife is over 3,000 meters high. So of course, if you have a wind that comes from the northeast, you will have a very long wind shadow, but you will have a massive acceleration zone in here. Beware also that this is a wind prediction. It does not take into account in detail the local prediction. It gives you a warning. But here, if I look at this, I'm looking at 25 knots probably predicted between Gran Canaria and Tenerife. I would not be surprised that locally here on that particular day, you would get 30, 35 knots or even more in some of the notorious areas. And the typical notorious areas is here, somewhere around the airport in Gran Canaria and here on the edge of Tenerife. But let's go now into, leave alone the funneling and the wind shadows, the local system that you really need to be very well aware of are squalls. The official definition of a squall, as Julia mentioned, is it has to have a wind increase of at least 16 knots with a top speed of 22 knots and lasting at least 1 minute. This is the official definition from the World Meteorological Organization. My definition is it is a local pain in my lower backside. That's exactly what it is, because it makes me happy or it makes me sad. It is a very local and very confined cloud-based weather system causing significant wind changes. And those wind changes are not only changes in terms of wind strength, but also significant wind changes in terms of wind direction. So it is not uncommon that as a squall is coming towards you, passing you, and going in front of you, that you have wind changes of 90 degrees, sometimes even 180 degrees. For that, it is really important of reading the sky. So apart from the waves in the Golden Alley, the clouds and the squalls will make you happy and sad. Typically, these cloud systems are small, local, maybe half a nautical mile to 10 nautical miles of diameter. 10 nautical miles is already a pretty big system. You can track them visually. As we're sailing downwind in the Golden Alley, you see them building up behind you. You see them coming towards you. Visually already, you can somewhere already guesstimate if this squall is going to pass on the left, on the right, or it's going to hit you. So you might adjust your course accordingly. And certainly if it is a squall of only a nautical mile of diameter, there's a good chance by adjusting your course, 10 degrees or 15 degrees further north or further south, you can avoid it. And definitely via the radar. Sometimes we even use the radar to really track precisely the squalls, especially if they're strong ones. So many radars can have a calculator that, just as we can calculate the CPA, the closest point of approach for an AIS vessel coming towards us, they also have a calculation feature where you can pinpoint to the center of a squall, and the navigation system, the radar navigation system, will calculate the CPA. How far will this squall pass me? And you can actually see the vectors just like for an AIS vessel. If you don't have that, you can use the bearing and the range cursor tracking with VRM and EBL to put a dot in there with a circular range, and you can track it as it is moving. And again, yes, it is possible to escape smaller squall systems. Even on, let's say, slower cruising boats. Now, the bigger and the denser the cloud is, the more influence it will have on your wind speed and the wind direction. So it is important to read the cloud. And for that, it is important to determine, are they blowing or sucking? Now, this is a Peter term. This is not a very scientific term. We talked about this with Julia, where I said I'm going very unscientific in my part of the presentation. I use blowing and sucking in my terminology. What does it mean? So to blow or to suck, that's the question. So sucking clouds are baby clouds. So these are clouds, young clouds that are building up their energy. They don't look threatening. They're typically smaller in height. They're lighter in color. They're clearly not built up yet. And they don't look threatening yet. So if you look from above the cloud, imagine you're in a helicopter and you're like 1,000 meters above that cloud, and you look down on the cloud, a sucking cloud, a building cloud, a baby cloud will suck wind towards its center from all directions. And the wind sucking will be moderate. It's normally baby clouds will not give you a 10 knot or a 50 knot of wind difference. So sailing downwind, as they catch up with you, they will first slow down the wind because the wind is coming from the back. They are sucking towards them, so they will somewhere kill as they approach you. They will kill your prevailing downwind. And once they pass, they will accelerate a bit. This might be a little bit complicated to understand, but I have a diagram to explain this. So they typically have a medium influence on the apparent winds, or even a low influence. So it is not unusual for a baby cloud, a sucking cloud, to pass you, and you can hardly feel it. There's like 1 or 2 knots of difference. There's a couple of degrees of shift in direction. Very often, as they're still sucking, building up energy, there is no rain, or maybe just a little bit of a drizzle that comes from those clouds. So this is a sucking cloud. You're now sitting in a helicopter 1,000 meters above that cloud, and you're looking down towards the sea, down on the cloud. So a sucking cloud, a baby cloud, is sucking all of the wind from all of the directions, 360 degrees around the cloud, into the cloud. It goes into the cloud and goes up in the cloud, and that's how it builds. And then if we're still looking at the cloud, you see your boat is sailing downwind. So here you see the prevailing wind, you're sailing downwind. So your boat is going in the right to left direction. So you can imagine, as this sucking cloud is approaching you, these winds here in front of the cloud, as they come closer to your boat, they will kill or at least lower your prevailing wind. And if it is a baby cloud which becomes like a teenager and it starts building up, it is not expelling energy yet, but the moment they really start sucking up, and the bigger they are, the more they start to suck up, it is very well possible when this baby cloud or this teenage cloud is now starting to approach you, that it will completely kill for a couple of minutes your prevailing trade wind. And then as this cloud is moving past you. Remember, here it's sucking still towards it. So basically these winds will accelerate the boat because the cloud is now here. So the clouds, the winds behind the cloud will accelerate your trade winds. So in that, if it is a teenage cloud that is already pretty mature, so it's sucking quite strong, it is very possible in a trade wind of only 10 knots that for a couple of moments you have no wind whatsoever. The cloud comes over you, and all of a sudden you have 10 knots from your prevailing trade wind, plus 10 knots of the cloud sucking, and all of a sudden you go into 20 knots. So you go from nicely sailing downwind with 10 knots, all of a sudden the cloud is passing over you, have no wind, and then you have 20 knots. But again, these are baby clouds, these are sucking clouds, so typically the influence is medium. Now, blowing clouds is a little bit more of a problem. So blowing clouds are mama clouds. So they expel and discharge energy, typically wind and rain. So they have grown, they have built up, and there is only that much of moisture, that much of energy that a cloud can hold. So at a certain moment, it will have to shed all of that energy. And they shed it in the form of rain and wind, or sometimes only wind. It all depends a little bit on the local circumstances. We'll come to that later. So visually, as they approach, you will see they are darker. You know, the baby clouds is not typically what my heart starts beating faster as a sailor as I see it approaching. But when I see the darker clouds, the higher clouds, and typically also with a rain shadow underneath the cloud, then my heart starts beating faster. If we look again from our helicopter view, from above the cloud, you will see that 360 degrees around this cloud, it will expel the wind away from the center. So it's just the opposite of what the baby cloud, a sucking cloud, is doing. So when you're running downwind, the effect of a blowing cloud, a mama cloud catching up with you, is just the opposite as when a baby cloud is approaching you. And that's why it is so important to distinguish between baby clouds and mama clouds, because the effect is just the contrary. So as they catch up with you, they will accelerate a bit because they're expelling energy. The cloud is catching up with you. And obviously, if you have a really, really, really fast boat, you can never outrun a cloud. So you're going downwind. You're going in a nice 10 knots, but the cloud behind you has so much energy that it expels 10 knots of wind. So your 10 knots of trade winds will be accelerated by 20 knots of wind that the cloud is expelling. So you will get an increased wind, in this example, 30 knots before the cloud. Very often in the center of the cloud, the rain underneath that cloud will typically eat up most of the wind. So it will go from 30 knots typically, or 40 knots to absolutely no wind whatsoever. And very often it's like a curtain. You can see the rain coming, and as the rain is coming, the curtain of rain is coming, your wind just dies. It's almost like magic. I find this fascinating. Now, behind the cloud, as the cloud is passing, because the cloud is expelling wind, the wind it expels when the cloud is now in front of you will kill your trade wind. So you might have low wind, possibly no wind because it's killing your trade wind, or possibly you might temporarily have an 180-degree wind shift if that mama cloud is coming in front of you and you have very light trade winds. And again, we talked about El Nino, and one of the effects of El Nino, as Julia said, is that we might go for a season where we have lighter trade winds, but because the sea temperature potentially will be much higher, we might have stronger and more frequent clouds. So this is something for me as a sailor, I have to be really aware of for the next transatlantic season. More squalls, stronger squalls, and combined potentially with weaker trade winds. That means that the wind shifts that typically blowing clouds will give us will have much more of an effect on our boat. So imagine you're not prepared. You're nicely, sailing downwind, in 10 knots of wind with your spinnaker. You're not really paying attention. And there is a mama cloud building up, and they can build really, really fast. You know, if you have a high cape, if you have a high sea temperature, it is possible that in half an hour, you can go, or in an hour, you can go from almost no cloud whatsoever, or a little bit of a fluffy thing, into a real mature mama cloud. You're not paying attention, and all of a sudden you're being hit by 30 knots of squall. And then as a squall passes you, 180-degree wind shift. If you did not dose that spinnaker in time, you're going to have a problem. And generally, because they're mama clouds, so they're pregnant with a lot of moisture and rain. They're shedding that rain. They almost always come with very short but very heavy rain. Not always, but most of the time. And in more extreme cases, when it's a real mature cloud, typically with a T shape, where there's a lot of energy up in the top of the cloud, this might include lightning. Again, in a diagram, how we're looking at this, again, from the helicopter, we have the mama cloud, which is coming. It is expelling energy 360 degrees around us. We have our nice 10 knots, 15 knots of trade wind pushing us downwind. My boat is moving, you know, in a nice 6, 7 knots that way. So as this blowing cloud, this mama cloud is approaching me, these winds here in front of the cloud will accelerate your trade winds. So it will be the speed of the trade wind plus the speed of the wind that the cloud is generating, more or less. And then as this cloud is passing you, these components of the cloud will then kill your trade wind, or at least lower the trade winds, or possibly give you a shift, that infamous shift of 180 degrees. So, in summary, as clouds are approaching, expect wind shifts. I mean, in the examples, in the drawings I made it very simple. The cloud is going straight over us. But even as the clouds are passing a couple of miles, you know, to our starboard or port, you will get effects. You will get wind shifts. I'll have some pictures of this where you can easily see the wind shifting, even if the mama cloud is is causing a squall that is like 1 or 2 or 3 miles away from me. You can get like 10, 20, 30 degrees of shift. So as the clouds approach, definitely reef. Dose the spinnaker. You might look at the clouds and look at the radar. You know, I see myself as a little bit more experienced, but even I sometimes misjudge the strength of the wind associated with the squall. So definitely dose that spinnaker or the code zero, whatever light wind that you're using, and possibly start reefing and start preparing for a shift. So be vigilant. Monitor the cloud movement. So keep the prevailing wind in mind. It's a nice exercise when you see a squall building up with the rest of the crew on your boat to say, okay, is that one going to hit us? Or is it going to part? Is it going to go upwind from us? It's going to pass us on the left or on the right? Or do you think that it's going to hit us? Can we maneuver enough to avoid it? Keep an eye on your wind speed and through wind direction history display for the shifts and the increases. Sometimes you already see it up, the wind shifts coming up, building up way before the cloud is hitting you. And definitely keep an eye on your radar. You don't have to have your radar on the whole time, but as visually you see them coming up. And even in dark nights, you will learn to see the cloud approaching in the darkest night. Hopefully you will have a little bit of moon, makes it a little bit easier. But even during the day, sometimes as we see them building up, we switch on the radar, do a bit of a scan, do a bit of a calculation. And if it is a real big system, a big, strong squall system coming up with a bigger, darker cloud, we keep the radar on and we track the clouds. So an example of the wind shifts generated, you see here nicely a squall that passed us. You see it didn't take very long. It was like maybe half an hour and the squall was over, but you see it's a significant, it was almost a doubling of our wind speed. Here is on a different display. I think this was a Raymarine. This is a BNG system. So you see a true wind speed spike. So we were nicely sailing at 14 knots of wind speed. You see here how the wind was eaten up as the squall approached. And as the squall passed us, you see the wind increase. So this was clearly a sucking cloud, which ate up our wind before it caught up with us. Here it caught up with us, and you see clearly the spike also in the wind direction. It increased the wind from our nice 14 knots to 20 knots. So this was not a disaster, but you can see how much it shifts. If you look at the wind shifts itself, you see that there is a shift of about 30 degrees as this cloud passed us, and that one passed us straight overhead. All right, this is how it looks like on the radar. I'm sure that you guys know this. This is the radar with heading up. You see here the different squall systems. Here we're tracking this with vectors. So I see the direction they're heading. You see the centers of it. So these are 3 different squall systems. They're quite dense. So these were all very small mama clouds. This one we were able to dodge. This one came straight over, and this one we're going to dodge because it's a bigger one. So we're going to go a little bit further to port side. All right, do a little bit of a visual exercise. These clouds, does this make my heartbeat faster? Nope, they're not even really blowing or sucking. They're, very light clouds. Typically, also these are clouds that are building around an island. I think this is as approaching Mallorca a month and a half ago. So, if this would be an open ocean, this would not be clouds that I'm really worried about. This would be like premature baby clouds, possibly. As a baby cloud, a little bit older. So here you see it's a little bit higher. You see already a little bit of a darker edge on the clouds. I see no rain underneath it. So is it blowing or sucking? Well, it's sucking. It's a baby cloud. So nothing really much to be worried about. All right, blowing or sucking. Well, look at this. This is now a little bit more clouded sky. You can almost smell more energy. You can feel more energy. I can definitely feel my heart start pumping a little bit more here. We see it's darker in color, and you can see like over here, the bottom is starting to get darker. So I might already have some rain underneath here. All right, this one is already now starting to have quite a bit of rain underneath it. So this is now turning into a mama cloud, clearly pregnant with wind. You see here the rain shadow already under it. So this is a mature cloud. This is a blowing cloud. It's not. It doesn't look like a very dangerous one. If I'm at anchor, it's definitely time to close my hatches because I will get rain. Not what I'm saying is not something that I would be particularly worried about, but I would definitely take my spinnaker down. That's for sure. This one is already a little bit more of a worry. So that one will definitely increase my heartbeat by 60 beats per minute minimum. You see, it's much more mature, much higher, much darker, and you very clearly see at the bottom of it the rain coming in. So what I would do here, if this is aft of my boat, I would try to avoid this area here, which is the strongest concentrated wind. So I try to go more on the edge of it. This one also is a very typical squall that you will see, a medium strength squall. Again, looking aft of our boat, it's higher. You see clearly it's darker, and you clearly see the rain underneath it. It's still building, so it might be by the time, depending on the cape and the sea temperature, it might be by the time that this squall is catching up with me, that it is bigger, more mature, and stronger. So it is very well possible. And you see here, it starts even to rain here at the edges. So it's possible there that the rain front is building up. This one will get me worried. If this is aft of my ship, as this picture is taken, we have not only a very wide squall system, we have also a complex one because I can see there's some higher winds in here. You look at the shape of the clouds, they're stretched. So it's a typical sign of higher winds. I have a very wide rain area, and it's expanding. The mama is still becoming bigger and bigger and bigger. So this is definitely a cloud that I'm worried about. You can see also that even up higher up, it is expelling energy. So this is what I'm worried about. This one, I would probably take as much sail down as possible. And as here, I think, Julia, this is a picture from you. Maybe even get the bimini tied down, because if this one is going to hit, it's going to hit hard. It's a very big system, dark, very mature. Is almost like a T cloud. I would not be surprised that this one is containing lightning. So that one for me is the worst scenario. You see how much energy is expelled here at the base, the wind's building up. And then a bit of a trick question. This is, we're sailing west. This is sunrise behind us, looking towards the east. So sometimes, as people know that I'm a bit of a weather buff, sometimes they wake me up by sunrise, not only because I love sunrises and sunsets, but also because they say, "Oh, Peter, you know, we look like it looks like there's a massive front coming towards us because as the sun is rising, look at all of these clouds." These are not clouds. This is humidity. So as the angle of the sun is very low towards the surface of the sea, sunset or sunrise typically, this here what you see is more the humidity that hangs above the sea rather than a cloud. So this is not a massive cloud system coming up. This is not a baby cloud or a mama cloud. This is not a cloud whatsoever. You have a little bit of higher clouds up here, but there's nothing to worry about. This here is nothing to worry about. This is humidity, which will evaporate as the sun is coming up and the air is drying out. As we said, can squalls be predicted? Squalls are local systems. I repeat this again. This is not taken into account in the gust predictions of PredictWind. Squalls are notorious spinnaker killers. Squalls themselves cannot be predicted, but, and this is important, the probability of squalls can be predicted based on a number of factors. And here is really the difference between what I call the chicken sailors and the eagle sailors. If you're able to master reading at your weather predictions and PredictWind, if you're able to master through experience the variability of the different factors that need to exist for a high probability of squalls and high squalls and possibly thunderstorms or lightning storms, then really you master a lot of what needs to be known for a safe passage. So a squall probability is more or less the sum of, first of all, a high cape. And PredictWind gives a really good cape forecast. Typically high sea and air temperatures. Many of our boats have sensors, but also PredictWind gives sea and temperature forecast. If you look in the PredictWind forecast, you can often see forecasted rain. So if you see forecasted rain, then typically it is an enabling factor for a squall, or it is somewhat a sign that there is a condition around in the area that we sail that is favoring squalls. Also, if you have a certain change of sea or air temperature, it is not uncommon that you sail across the Atlantic and in 24 hours, the sea temperature goes up by 2 degrees or 3 degrees. A certain change in sea or air temperature is very often an enabling factor for a squall. And of course, as Julia said, if I had a squall already at the beginning of the night, it is very probable I'm going to get more squalls during that night. And then the counterfactor is a Sahara dust, which is more a damping factor, but that you can only see visible. There is some Sahara dust more towards the Cabo Verde, blah, blah, blah. But then as you go more towards the Caribbean, that is less of a damping factor. So if you look at the predictions and you see a cape of 1,000, and you see, you know, sea temperature is like in the 30s, you know, in the lower 30s. air temperature is in the 30s. You see that there is little bits of forecasted rain, smaller dots. Then that by itself means that it is a squall enabling environment. If all of it is high, if you see a cape of 3,000, 4,000, if your sea temperature is in the lower 30s, your air temperature is in the 30s, and you see those dots of forecasted rain, then almost guaranteed you're going to get squalls very soon. Remember, the closer to the Caribbean, because the sea is getting warmer, the air is getting warmer, the energy is building up, you will have a higher probability of squalls. So it's very well possible you sail from Cabo Verde to Barbados. For the first couple of nights, you have no squalls. Once you reach somewhere midway point, you might get squalls every single night, or even during the day. Simply because the higher temperatures create a higher cape, which is feeding all of the clouds. So the higher the cape, the faster also the clouds will grow. And you will probably see if you go through an area of a high cape, and typically the closer you get to the Caribbean, it is very well possible that you have a nice sunset and you see almost no clouds whatsoever. And then as the sun sets, you're going into the night watch. It is very well possible that in just a few hours' time, the clouds have built behind you, although you could not see them at sunset, not at all, clear sky. It is very well possible that in 2 hours' time, depending on the cape, in 2 hours' time, full matured squalls will hit you, even though there was nothing to be seen at sunset. So be vigilant the closer you get to the Caribbean. Again, as Julia mentioned, squalls occur the most frequent, but not only during somewhere the night, very typically late night, early morning, because of the temperature gradient, the difference between the sea temperature, which is higher, and the top of the cloud temperature, which is lower. So that temperature gradient, the higher it is, the higher the probability of a squall. And of course, that gradient is the highest long after the sun is gone. But you might have a very enabling squall environment with a very high cape, very high temperature during the day, high sea temperature. So squalls might even hit you during the day. But again, most frequently, late night, early morning. Will squalls kill you? Nope. I've done now guided a couple of fleets. I don't think that anybody has ever been killed by a squall. But if you are unprepared, squall will potentially damage the boat, rip your spinnaker, or hurt people. So it is not a squall that kills you. It is being unprepared, not monitoring, not paying attention, that will create damage or havoc. So monitor closely for stronger squalls, including also for lightning. So I use lightningmaps.org. You look at the Cape. I also try, when I see other sailboats, I try to, on VHF, keep in touch with them. And as we're moving with Finding Dory, we typically give 1-day observations. But also when we go into a high squall area, typically on the chat, people warn other boats that they get into a squall area. So it is easy to see where the boats are around you and which boats to keep an eye on. And maybe even, chat with them and say, hey, you're in front of me, or you're in the back of me. Or you're north of me, south of me, keep me informed. I don't like the Cape figures. I don't like the sea temperatures. This look like a squall time. Just send me a WhatsApp, if you get hit by a squall, or even more important, if you see lightning or you get hit by a lightning storm, and definitely watch the skies. And beyond that, I hope that your sky will always be like that, and you can put your feet up and just cruise along to the Caribbean. All right, Julia, can you unmute? Right on time. We said 2 hours. Are you back with me, Julia?
I'm mute. Sorry, I'm here.
Yeah. So what do you think? Do I qualify like a beginning amateur meteorologist, or what's going over here? What's the point from the Australian jury?
Oh, no, there's a solid 10. No, you did it. You did a very good job. And I thought that as we mentioned, Peter, as I mentioned to you, I struggle reading the clouds. I know a lot about meteorology, theoretically, but when I'm out, I do struggle. And so I learned a lot from you with respect to, your pictures and advice of where to put the boat when the clouds are coming. So that was really good. Thank you.
But thank you, thank you. Well, it's a good combination, I think, where we look at the wider stuff, and the systems there are, as well as the local systems. We're going into questions. Before I go to the questions that we had pre-prepared, I'll go through the questions that we had in the chat channel. From Nancy, and this one is going to you, Julia. Nancy says, we've heard something about Cape versus Sin, CIN. Is it true that the relation is more important than the Cape alone? To be honest with you, I've never heard of Sin. Please go ahead.
So sin is convective inhibition. So it's the inverse measurement of CAPE. Um, it is slightly different. I mean, you will notice that sin is not really often, you don't really have, I don't think you have a sin layer in windy, and I'm not sure if it's available in predict wind. I don't really often see it in forecasts. So the thing about sin is, whilst it does counteract CAPE, the reason why we don't look at it a lot is because it is a lot more variable than CAPE. And it can often change in a day. So, generally speaking, over land, you get thunderstorms and so forth in the afternoon. And usually that is because in the morning you have a higher sin, and obviously you need the energy to form underneath. But convective inhibition happens when you have temperature inversions, so you have a layer of stability that basically puts a cap on the activity that's happening underneath. And then often what will happen in the afternoon is you'll get enough energy underneath that system. I'm talking over land here. You'll get enough energy within that system to sort of punch through the convective inhibition and then generate a storm. And then sometimes in the afternoon, the convective inhibition will just disappear. The only people I know who actively look at sin in their weather forecasting are the people, you would have heard of storm chasers, people who go looking for,
Mhm.
really big thunderstorms. They actively look for convective inhibition, because if you have a convective inhibition in a morning, and then you have conditions that with a high CAPE, then that is when you can get some very, very intense storms, because then the inhibition caps the CAPE, and then eventually it needs enough energy to push through it. So you end up with, quite a rapidly building, quite a violent storm. So whilst sin is important, when we're looking at things generally and forecasting, from sort of like a day-to-day standpoint, unless you're sort of, Nancy, unless you're out there sort of chasing a storm or, actively monitoring it. So sin is important, but it's definitely much better to watch the CAPE and not worry too much about the sin. Um, Particularly as we talk about CAPE, it's there, it's just as a guide, and there's probably other things other than convective inhibition that you can look at to sort of give you an idea of how likely a CAPE is to sort of develop into a system.
Yeah,
So
and the CAPE is also predicted like days in advance, almost like the wind, 4 or 5 days ahead, is quite reliable.
yes, yes. So CAPE is definitely a lot more reliable, a lot more stable sort of figure, whereas SIN does tend to vary a lot more sort of during a day. So it's definitely a lot more difficult to sort of take a snapshot of convective inhibition and like you said, have a look at how things might be in 3 or 4 days' time. So yeah.
Also from Nancy, and I think it relates to your line in your slide that there was 60 something percent of a super El Nino. By when will we finally, you meteorologist, by when will you make up your mind whether we're going to have a super Nino or not?
So the way the El Nino is calculated at the moment, it's actually calculated using something called it's called the El Nino Southern Oscillation. You may have seen it
Mm-hmm.
somewhere. It's
Mm-hmm.
ENSO 3.4 is, I believe, the algorithm that we use at the moment. And at the moment, it used to be we would use a pressure differential, but now currently we use a sea surface temperature differential. And I think the current ENSO 3.4 is like 2.7. I don't know. I don't off the top of my head where that sits in terms of how high or low that is. I think anything over like a 1.75 puts you into an El Nino. But Nancy, I probably should get back to you on that because there are resources that I can pass on to the group that will give you an indication because obviously it's June now, and you guys will be thinking about crossing in November, so the picture will be very different. We will know by November. Um, and I'll find some resources and I'll share them with the group that you guys can have a look at and just get some information as far as how things are tracking. Usually it's updated monthly, and then you have like a expected forecast sort of for in 3 month chunks because it doesn't tend to vary very much. But I mean, I think that right now we can say that in when you guys cross, you will definitely be crossing in El Nino conditions. The question mark is how strong will those El Nino
Yeah.
conditions be? So.
Yeah, but we count on you on keeping us up to date as the transat season is starting. Has it started already, El Nino?
Yes, we are definitely in El Nino conditions right now. But they do, yes, but they are expected to strengthen. Usually, I think they strengthen. I think it's September through February is when they tend to peak, and then sometimes they can last over a year, but generally, it is that time. So.
Yeah, there was one thing, and this is a question from me. When you talked about super El Nino, you talked about possibility of wind shear. Can you explain a little bit what wind shear is? Because this is also important for us as sailors. What is wind shear?
So wind shear, you get wind shear when it's basically when you have two different layers of wind at different heights going in different directions. So I'm sorry, so I have one going, so you would have one layer of wind going, say, north to south, and then a wind layer above it going south, east to west. And that
Hmm.
difference in direction creates a layer of friction. Wind shear, if when you're looking at big storms, so tropical storm development, wind shear is a very good thing because it helps to reduce the size and the intensity of the system. Um, but then in smaller scale systems, wind shear can be less of a good thing because in like small squalls, you can get water spouts. Now, water spouts are not tornadoes or anything like that. They're not that powerful, but you can get water spouts, and they could very small, but they can do things like that. So, and wind shear can also cause, and this is something, Peter, that you sent me some information on from I think a meteorologist in the group, Kai.
Yeah.
You can get very localized conditions, and it tends to be at nighttime when you have like stable conditions near the surface. There was some cruises on Transat last year, and they had a phenomenon that was called tropospheric ducting. And what
Hmm.
that caused is it caused them to have very, very long AIS signals. Um,
On
and
VHF radio.
Oh, sorry, yeah, so very, very long VHF signals. And so what was happening was those signals were bouncing through a duct in the troposphere. But basically, it was formed through layers of stratification on the wind layer, and you basically have two layers going, say, south to north, and then a layer between them going west to east. And what happens with that friction is it creates a surface where the radio wave can bounce off, but it can also create a tunneling effect where and I mean, what everyone's heard of the jet stream. It's basically like they're called nocturnal jets, and you can get their small scale features closer to the surface, and you can create a tunneling effect with wind. And sometimes they can reach the surface, and I believe the boat they had very, very strong winds at the surface, but their
Yeah.
anemometer at the mast was not tracking the winds.
Yeah,
So
it was this West-East Transat season. So it was just a couple of weeks ago, that example. Yeah.
okay,
Yeah.
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 So,
So they had in the middle of nowhere very nice sailing, and all of a sudden they could hear a howling wind. And I think it was like 30 knots or something they were experiencing on the surface, in the boat itself, but the anemometer was not registering anything. So it was very local on the surface. and almost like an updraft or a downdraft of wind. So unfortunately, also with Super El Nino, the chances of wind shears are increasing. And this is very different from squalls, but it's somewhere, a similar system that we need to be aware of that might come up. And also they are not trackable on radar. So also that boat that had a wind shear, they could not see anything, but they heard it coming. They heard this massive howling coming towards them. I hope we're not really freaking out people here too much. Also from Nancy regarding Windy's wave data, the period listed under the map that she is sharing here in the chat is for the swell. Do I understand it correctly that we should look at the wind wave period, which is not shown on the data in the map?
Yes, yes. Okay, so the windy the wave overlay is really useful, but it can be a bit confusing sometimes. So this view and I'm pointing to the chat with Nancy's image. I'm hoping everyone can see what I'm talking about. So this is called the meteogram, and this breaks down the swell. And you're correct, and it is a bit of a limitation in this view, Nancy, that there is no period on that wind wave at the moment. But what that wind wave is it is actually it's the dominant wave. And if you were to see the big X, if you click out of the X and then you're just on that point and you haven't like zoomed in to get the meteogram and you get the breakdown, what you will see in that forecast is you will see the wave height and you will see the wave period just on the general view of windy that's not the meteogram. And what you will always see in that particular view is you will see the wave period of the dominant waveform. And that is basically the waveform, which is the one that you are going to like be feeling the most, which has the highest significant wave height. So that is basically always going to be, well, sorry, in most cases, that is going to be your wind wave, unless you have exceptional conditions where you have very little wind but so you will be able to see that. It's just not in that view. I don't have windy open at the moment. Otherwise, I'll see if I can put something in the chat whilst we're going along, if you like, so you can see what I mean.
Yeah, very good, thanks. Then from Grant and Ursula, how about the dew point as a variable to use in conjunction with CAPE? This was probably in relation to the trying to predict the enabling environment for squalls. Dew point.
Yeah, dew point is something that you can certainly use. I mean, I must confess that for me, I get sort of lazy and I use Cape more. But dew point is something that you can use because it's giving you an idea of the humidity in the atmosphere and how that relates to how that relates to the conditions. It's not something I use, but yes, you can use it, and I can get you some more information. I apologize, I don't have really good information to hand about some numbers and some figures in which you could use. But yes, you can use dew point to sort of it's a measure of humidity and how it is in relation to. But it's I mean, obviously, the higher the humidity, this is high humidity in Cape, definitely. And it's we should probably put that on the list, as far as like you said, the our assessment of, okay, what are the clues? High humidity is definitely, if it's humid, if you've got one of those nights where you're just sort of sitting there and you've got that like that high dew point and it's just really close to temperature, it's muggy, thunderstorms. Yeah, it's actually a really good
I should
point.
probably put this in there.
Yeah.
So you have Cape, possibility of rain in the forecast, high sea temperature, high air temperature, and then just feeling on your skin, like, ooh, my t-shirt sitting here in the cockpit, my t-shirt is getting wet, or even the cockpit getting wet.
Yes, exactly. When you're on night watch and you have the condensation, yeah, that is true. It's a good point. Yeah. So
I should
no,
probably
that's
add
a
that.
very good point. Very good addition to the squall clues. Yes.
Okay, very good. Then on the questions that were sent in before the webinar, I'm going to a different screen here. One question was about the heat waves currently in Europe. How could that affect storms that we're going to have in the mid this summer? As many of us are still making our way through the mid to reach the Canaries. we actually saw a post today that brought back this question, and they sent me a screenshot. So currently in Europe, and we talked about this yesterday and also just before this webinar, amongst the I think 3 or 4 of us that joined in early. So sea temperatures at this moment are very high. And definitely everybody read in the news the extreme heats that early in the season in Europe. And there is a prediction now that there seems to be a second heat wave already on their way. How will this affect the possible storms and the weather in the mid-summer?
Yeah, definitely. I mean, if I'm sure a lot of you have done a lot of sailing in the Mediterranean. August, September traditionally, for me, I did five seasons in the Mediterranean. September was always the time where we would be the most concerned about squalls. And to have these heat waves early, because we're still in June, and if you recall, there was also a heat wave in May, which was very, very early. These do tend to be, we do have our hottest global temperatures during El Nino. So, that is tracking. Obviously, we're not yet at the warmest part of summer. I mean, it is concerning, as a meteorologist and a climatologist, these conditions with sort of, we're very concerned about the extreme temperatures and the records that could be broken moving forward. And in terms of how that translates to sailors, Peter, you mentioned the very, very high sea surface temperature anomalies. I think you were talking about a +8 sea surface temperature anomaly, which is extraordinary. A +3 is a big anomaly. And that just it means there is energy for storms. I mean, as I said, I'm not sitting here trying to sort of concern you all and make you all nervous, but it is there is definitely an increased likelihood as a consequence of that energy that is getting stored in the Mediterranean, of significant squalls. I think someone mentioned before we got going, the increased potential of a Medicane, and yes, that's certainly something that is more likely. So it's certainly when we are under an El Nino and when these conditions are like that, it is definitely a good time to sort of, as I said, err on the side of conservatism as opposed to, the other way. Be the chicken, not the eagle. I think that was the analogy you used, Peter.
Yeah, exactly. For those who were not in our conversation that we had before the webinar started, I live on the coast here, close to Rome. I took a dip in the sea a couple of times last week, and the sea temperature was 29 degrees that I measured on my watch, and 29 degrees in June. Normally, the temperature of the sea close to the beaches is only that high here in this area of the Med at the peak heat somewhere in the middle of August. And now we have that temperature already in June, where typically the weather here in June in this part of the Mediterranean is still quite unstable. And it's possible that we have, in the past years that we had days of only 15 degrees or something. But not only the air temperature is way above it, but now in the observation is we're 8.8 degrees sea temperature above average. That early. And it's all about energy. If the sea temperatures are high, the seas don't have that buffering function anymore to somewhere stabilize the weather, and it just creates a massive cape. I'm routing a boat that was supposed to leave tomorrow from Elba to Tunis. I saw in the forecast that we have a cape of 4,000 for 2 days and 2 nights in a row on that track. And that is almost like a recipe for lightning storms. And we just had one that passed just north of me as we were giving this webinar. Also, typically the lightning storms close to the coast, with the interaction between cooler air on the mountains that we have here a little bit further land inwards here in Italy, versus the warm sea, humid sea air, that collision and creating thunderstorms. Normally we have those conditions in like middle August and then the strongest later August and September, but not that early in the season. And now we had lightning storms every evening for the past week already.
Yeah.
All righty. All right, I had a question coming in from somebody who was planning to summer shuttle between the west coast of Spain and Portugal to the Canaries, maybe going Madeira, maybe going to and fro a little bit. And he was asking the question because he said, "Hey, listen, but the weather that I'm seeing in the Med, maybe it's not the best place to be for the summer." So I'm maybe going to cruise around, going north south between Madeira, the west coast, Spain, Portugal, and the Canaries. But is there a specific weather pattern that I can expect, which would enable me or not enable me to, easily cruise between Canaries going further north to Madeira, back to Portugal, and then back down again? And this was for the range as of December, all the way up to the beginning of the winter.
So we're talking summer cruising?
Yeah,
Oh,
summer
yeah.
cruise. Yeah,
So, and Peter, this is probably something that I think because I know you completed a transat back, but so you might have some practical aspects of this. But from my perspective, I mean, sailing out in the Atlantic, obviously the Mediterranean is a bit of a bowl, and the energy that is in there does concentrate. And we see that in the Cape. You see that in the sea surface temperatures. So from those things, being out in the Atlantic is, I can see the benefit from it. Obviously, in the Atlantic, you are more exposed to, the big swells that come from, the mid-latitude storms that are above the Azores High. And as, because we are past the solstice now, so, that Azores High is tracking south now. Obviously, there is a lag, and obviously there is a big lag from the weather. But I mean, I think that, you will just have to be cognizant of that system as it tracks. And at the moment, I mean, obviously with El Nino, there is a reduced likelihood of tropical systems developing. But because you are out in the Atlantic, those tropical systems, they do have a track, and they can cycle through, and they can affect Europe, and they can affect Madeira and the Azores. So that would be something you would need to just bear in mind. And if you're comfortable with being able to sort of move, I mean, where you are in that region, you will obviously have a lot of notice for those systems. You'll have the ability to take shelter. They won't hit you as tropical systems. They will hit you as extratropical systems. So you will need to bear in mind keeping those whilst you're in the season, and then after that, you will have like your your North Atlantic storms tracking further south. But again, those things are pretty well forecast, so you don't really have any surprises there, and you probably will have, whilst you are still going to get thunderstorms, as things get warm, because you do still get thunderstorms in those areas, they will be, I would say, more predictable and less intense, because you don't have that. I'm going to call it a pressure cooker environment of the Mediterranean, which is really tracking very warm at the moment.
yeah, yeah, yeah. And also, I think in the Mediterranean, very often the systems don't move that fast. So it very often, like we have now with the heat wave, the system was more or less stuck, over the
Yeah.
Mediterranean, while in the more on the Atlantic side, things keep on moving. I think it's also, slightly cooler to sail there.
Yeah.
It's definitely, on a practical point of view, it's definitely less busy than in the Med, typically in the summer. And I predict that if these temperatures continue in the Med, that more and more people will take to the sea, and more people will take to the coast. So it will get more and more busy. And indeed, I agree with you, Julia. I don't see anything which is inhibiting people to shuttle in between west coast of Spain and Portugal, Madeira, the Canaries, and going back up again. I don't see anything inhibiting, but it is all weather dependent because you will still have the pressures moving over. And as you say, the remnants of possible hurricanes that go through the Caribbean and then kind of slowly die off might have quite a bit of an effect of the weather. There's definitely looking at the weather forecast. Okay, passage advice for Gibraltar, we covered that. Okay, how far south should I need to go for east-west transit? I think we covered that really extensively. Question of how super El Nino will affect the east-west transit passage. We also covered that. All right, crossing to Brazil is different than a transit to the Caribbean. Best routing. So you covered it more or less in what to expect. But best routing, I mean, we talked about from the Canaries goes south-southwest into the Golden Alley, 14 degrees towards the Caribbean. I think that is pretty a standard recipe. But probably going to Brazil and diving through the doldrums. I'm not too sure if there is somewhere a golden best routing advice that we can give. I'll pass it to you, Julia.
Well, I think that probably the best thing I can say is I would need to take that under advisement and do because I have not actually routed anyone to Brazil. The furthest south I've routed anyone to is Suriname. But once you do get sort of further south than that, there are very, very strong currents along the coast. And those currents do sort of push you um up towards the northwest. So you potentially, as you mentioned, Peter, potentially what you would be wanting to do is you would be wanting to sort of cut through the ITCZ early, and then shoot across because otherwise you are going to be dealing with those currents and the currents opposing the prevailing winds. And especially, something very, because obviously squalls with currents because, you can have very, very strong gusts, very, very strong straight line winds, and you can get very, very um, dangerous transient sea conditions in that. So I think that one I have to keep that under advisement because I don't know, but that seems to me that might be something to do. But yeah, that's probably something we'd have to get back to people on.
Yeah, yeah. I think it's depending on the also on the wind conditions and where the trade winds are and where the doldrums are, how wide they are. I think one of the main decisions would be where am I going to pass the doldrums?
Yeah, yeah.
We had one boat in the previous season who went to Cabo Verde very, very early in the season. I think it was September. And they were the first boat to cross the Atlantic, but they went to Brazil. So from Cape Verde, they went almost straight south, went through the doldrums, and then just south of the doldrums, they routed over to Brazil. But it also depends, where you want to go to Brazil. You want to go to the northern part of Brazil, or you want to go more south. So I think the critical decision to be taken is where will I pass the doldrums? But is also the activity in the doldrums? What is the cape where I want to pass? And then definitely, take into account that you don't end up too high north in Brazil and then have to dive close to the coast to get where you want, because then you're going to have the strong currents against you. I agree with you.
Yes. But and just to reinforce what you said, it would actually be a very good route to do early because once you are diving south of Cabo Verde, then your likelihood of because hurricanes won't cross the equator. So you could basically do that anytime because you wouldn't really have, aside from some swell, you wouldn't have an impact from any tropical system. So yeah, that's a good point.
Yeah, exactly. One thing that we have to keep into account, though, is that, of course, tropical storms are somewhere building up as of West Africa. And then they're building up and then turn themselves into hurricanes. But even if it is not a hurricane, they might still be reasonably strong tropical storms, even that early as Cabo Verde. I think last year it was Cabo Verde was hit by what was to become, I think it was Hurricane Erna.
Yes,
And
it
I
was.
think I think it was late August or September or something, where they were hit with like 40 knots of wind. but with a massive downpour that actually flooded Mindelo, the area that we normally stop in. So there might be, reasonably strong tropical activity, at the latitude of Cabo Verde. But as you said, once you go through the doldrums, the tropical storms, potentially hurricanes, don't cross that. On the prediction software, what models do you typically use? But you mentioned that already, huh? You mentioned ECAM WF.
Yep.
Yep.
Yep, definitely ECM WF. And if for anyone, if you're ever trying to decide between a model, if you're ever trying to decide which, it's if you always check the model resolution, if you always go for the highest resolution model that you can, that's always a really good guide. But if in doubt, the Euro model is always going to give you a really good, robust forecast, for sure.
Yeah, and we're talking, of course, for global models and for transatlantic sailing. There's
Yes.
other models if you sail in Europe, which are more localized models. Rome is a very good one, but only does a forecast 2 to 3 days.
Yes.
Very precise, high resolution. But then if you're talking transat, for me, I use ECMWF and I use GFS to compare.
Yeah.
If the two agree, then I'm happy. If they don't agree, then this means that there might be some variables in there. And I use Predictwind for that. I use Windy for currents, although it's not very scientific, as you mentioned this before. But mainly I use Windy for real-time satellite images.
Yes, that's a very good feature.
Yeah, so I can actually see clouds moving, or I'm sailing through an area which has a very high cloud cover. I can see and windy in real time what these clouds are doing. Some regatta sailors actually use windy to look for the clouds, to look for the wind, because they give good real-time satellite images. And then beyond that, they use lightningmaps.org for lightning information. So these are basically my main tools for in passage sailing.
Yes, but just I will say on that, and I would be interested in your feedback on how you feel the lightning apps go offshore, because the lightning detection, there obviously there are a lot of monitoring stations on land. We also use satellite data. So I haven't actually validated this, I haven't researched this, but my presumption would be that it's probably a little less accurate offshore.
Yeah, quite a bit less.
Yes,
Quite a bit
yes.
less. Yeah.
So if you are going to use one of those apps, because they are really very accurate coastally, they're amazing. But yeah, just offshore, don't rely on it, because it will be less reliable because there's fewer data points. I mean, you can to say not rely on it, just don't expect it to be as reliable as it is coastally. Does that make sense?
Yeah, totally. For those who don't know lightningmaps.org, it is like a crowdsourced system where people have sensors that measure electromagnetic pulses and directions, and then use different of these sources to triangulate the location of the lightning, and it's real time. And as Julia said, in coastal areas, because of course you have more people that have these sensors installed at home, you get very, very precise mapping. I use this all the time, close to coast, definitely here in the Med, when we sail close to shore. Even over here, to expect, do I have to close my windows tonight because we can see the lightning moving. But of course, these sensor systems are all coastal based. And if you have to triangulate of a lightning hitting 1,000 miles away, it becomes less precise. But it's a good indication combined with the lightning predictions and the high cape in Predictwind.
Yeah.
A practical question: Predictwind. They're gonna get me on my high horse here. Predictwind gives you. If I haven't been on my high horse yet, I will get on my high horse. Predictwind gives you a suggested sail routing. How religiously do you follow that sail routing in Predictwind?
Do you want to go with that one, Peter? Sounds like,
She goes like, you go for it. Yeah. Listen, just like the wind forecast and the cape forecast and the rain forecast and the blah, blah, blah. For me, sail routing is just one other piece of advice. So sail routing is, for those who don't know it, you have point A and point B, and you ask predict to, based on the number of parameters of your comfort level and your boat parameters and your sail parameters, you ask predict to suggest, based on the different models, what the best optimum sail routing is. And you can do the routing based on comfort. You can do it on time, on the fastest track. But to me, I often compare it to the science between a GPS and a car calculating the best route to go from A to B, where very often my experience has been that my GPS is telling me to go into a side street, then another side street, then another side street. Well, maybe I'm losing only 1 minute if I stay on the same main road without having to do all of the turns. Very often, predicting makes way too complicated routing than what is necessary. Knowing also that very often, if you follow the routing, that you might have to do a number of sail changes for which you need crew energy. Every time you do a big sail change, certainly if you sail big sails, is always a potential hazard because you have people at the bow, you're working with big sails, blah, 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 blah. So I'd rather in the routing stay lazy and maybe for a day go a little bit slower because probably I'm going to gain this anyway the day after. I have been on boats where actually the skipper downloaded the PredictWind routing into the navigation system and was not very happy if I deviated from that particular route as it was predicted. And that to me makes absolutely no sense whatsoever. Because I don't care whether I am 5 miles of my predicted route or 10 miles, because the local conditions are, the sail conditions are that, or, I don't like particularly the wave angle, so I'm looking for a little bit more of a comfortable route, or the way that we have the sails trimmed, the boat goes nicely fast, so probably I'm going to gain it out in VMG. So I tend to be in passage a pretty lazy sailor. And I'm not religiously dedicated or following the PredictWind sail routing. On top of that, people forget that any tool like that is only as precise as the parameters that you put into it. And for PredictWind to do a good sail routing, you need to be very precise in the polars that you put in there. But PredictWind only has very limited parameters. I think it is, okay, at 50 knots of wind on 3 different sail angles, what is typically the speed that your boat is doing? Which to me is absolute bollocks, because that depends on the sea state, amongst other things. On top of that, it only gives like 3 angles, but my boat sails on many different angles. And my sweet spot might be, I don't know what, 55 degrees. That's how my boat with the sails that I have sails the fastest. But that is not a parameter that they have. Unless if you want to do very, 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 very complicated polar predictions. For me, on a passage, the comfort of my crew, the making the skipper happy is much more important. Conserving energy of the crew in less sail changes, and not sailing on the edge of things is much more important than following the sail routing. Sail routing is advice. Most of the time, 90% of the time, I don't agree with the sail routing anyway. And there's me as a cruising sailor, but even as regatta sailors, very often we go like, what were they thinking? Where does this come from? Amen. I just fell off my soapbox. Do you have anything to add to this?
No, I agree. I agree with everything that you have said. I mean, it is a useful tool. But yes, I think that, just like, I mean, it is based on weather models, and we've established, as we've talked about, there's errors in space and time in weather models, and as soon as you put assumptions on top of assumptions on top of assumptions, then you are sort of building your sail route on a bit of a house of cards. So. I think really useful tool, but I think everything else that Peter said, I 100% agree with. So
Yeah. There was a question on crossing further to the Galapagos, Marquises. I would not want to cover this now in this webinar. We might see if somewhere towards the end of the season, if we want to go into that. We just added the West-East transatlantic passage to our portfolio of what we want to support in Finding Dory, but I would want to go further than that. There was one more question. We partially covered this. If you go from the Canaries to Cabo Verde during the summer, can you cross to northern Brazil or Suriname late August, staying clear of the hurricanes? We partially covered this, but maybe we can reiterate northern Brazil or Suriname.
So, as you're getting close to Suriname, I mean, traditionally, if you, I think for insurance purposes, a lot of people say 10 degrees. But I mean, there are things called, like Peter mentioned before, the tropical storms you get, in the summer you get these tropical waves. And if you're ever having a look at the satellite view on Windy, you can see they start in North Africa, they move over Cabo Verde, and there's just these like blobs of thunderstorm activity that move across. And these tropical waves can be very, very intense. And they're obviously not a tropical storm, but I mean, they could be what three knots below a tropical storm, and then it's just going to get flagged as it's not going to be reported in the same way. So yes, I mean conceivably you could, but I mean I would say that is not you. It's definitely more of an advanced route, I suppose. It's you're traveling in more challenging times, and you are still so you would be threading a needle between the intertropical convergence zone and the tropical storms.
Yeah,
The climatological peak of the storm season is August, September. They're the two busiest months. And
yeah,
they are also the time where we call the Cabo Verde region the main development region. That is like the main development region. And they are generally the storms that develop there. Not always, because you get a lot of Gulf of Mexico storms, but Cabo Verde storms do tend to be, some of the really big ones that, cause a lot of damage because, they sort of swoop through and they have that track that follows the Antilles and the Bahamas chain. Um, so, they're not systems to be trifled with, but I mean, as I said, they are very well forecast. It is a potential, but you are traveling in the time where that Atlantic basin is going to be producing its most intense, biggest storm. So, it's something that you'd need to factor in. And if I was doing weather routing for you, my advice would probably be maybe you want to wait a little bit, but that's
yeah.
something to think about.
Yeah, yeah, yeah. I wouldn't take the chance for sure. I think there's a possible route from Cabo Verde straight south and get into the southern trade winds, but you never get to Suriname from there, unless if you want to follow the coast then up from Brazil, but then you have to go through the doldrums again, and to me it really makes no sense to do it in the summer, even late August. I would say probably early November would be the earliest, and even then I would rather go for a safe bet of mid-November at the earliest. Personally, I think that the arc is leaving a little bit early, with lighter trade winds. I typically like to wait a little bit until the trade winds are a little bit more stable and well established later in the season. Like December, mid-December, even the Christmas trades. Normally I don't like to leave very early in the season. But again, people want to take advantage of the Caribbean season. I want to
Yes.
leave early enough. That's probably also why the ARC and the ARC Plus are leaving so early. Yeah. We've gone. There is one more from Nancy. We're going to take this as the last one. So for a comfortable crossing, do I understand correctly that the ideal wave direction is as far aft as possible, and waves on the beam is the worst? You want to take that?
Yeah, I can. I'll give my input, and then I think Peter. I mean, so Nancy, this is also very, very dependent on your boat and how it goes. I mean, I do find for me with my boat and comfort, a quartering wave, sort of, off the aft quarter. We did have seas that were sort of predominantly we were dead downwind. We had the waves behind us. It was pretty comfortable. I don't like waves on the beam. From boats that I have routed across, they have had waves on the beam with light winds, and they complained a lot about it. A lot of stress on the boat, a lot of movement in the rig, chafe as a consequence, because obviously they had light wind sails up, so, but anyway, but it is very dependent. I mean, and my experience is limited to, monohulls around the 40 to 50 foot mark. So, um, yeah, I understand it's quite different if you're on catamarans, and bigger boats. So, perhaps Peter, because you have many, many more hours at sea and miles at sea, you may have some more input on that too.
Yeah, definitely on a monohull, waves on the beam are probably the worst, and definitely on a cruising catamaran, because you will get the waves banging one hull, coming underneath the boat, banging that horizontal platform, and then they're going to bang the leeward hull. So you're going to have three banks, and if the waves are significant and steep, three significant banks that will definitely wake up the skipper on a cruising catamaran. A little bit less on a performance catamaran, but even then, probably waves from the back are more comfortable. On a monohull, it really depends on the boat. But one thing that we need to take into account, very often we don't have a choice, because we sail mostly with the wind as our main parameter, because we need to get moving. So it is more difficult to do a routing combining speed, comfort, and sailing with the least of sail changes together with wave routing. I once crossed on a cruising catamaran. It was the first time where we really had to take the waves into account because it could not be too broad, because we had a lot of banging. And that was a very complicated routing that we take. And sometimes we would go nice and fast because we had a good angle to the wind, but we had to slow down and change our course because the waves were probably going to break the boat apart with all of the banging. So it really depends on your boat. It also depends on the speed that you can have. So typically, I like to sail on a fast boat because we tend to be less pushed by the waves and moved by the waves. So on a monohull with a wave, even from the back or from the aft quarter, we're going to have a lot of rolling. But if on a fast boat or under a good speed on the boat, that will have less of an effect. That would be a bit but very often you don't have a choice. You just have to go in that particular direction. You have the wind, you need to move, and you just have to bite your lip. That's it, Julia. Thank
Thank
you very
you.
much.
It was a pleasure. Thank you for sticking with us, everyone. Yes, it was really great. And I think we're going to share the presentations and maybe
Okay. Yeah. So if you send me the PDF, I'll make a PDF of mine, because I think beyond all of the other webinars, I think it's good that people have an easy read on the stuff that we present.
great. Yes. Thank you very much.
Thanks everyone, and thanks again, Julia. We'll stay in touch. Thanks, guys.
Okay. Bye bye. See you.
Bye bye.